Good afternoon, all. So we will start our sixth day of Adal FTP very shortly. Good afternoon, Srinivasan sir. Uh,
Hello.
let- yes, sir.
Hello.
Yes, we can hear. Yes, sir. We can hear you, sir. Clear.
Hello. Good afternoon to all.
Yes. Good afternoon, sir. Good afternoon.
As it was a working day for us, I had some other responsibilities. Sorry for the delay happened. So
It's okay, sir. Then I will. We can start the session there.
yeah.
One,
Uh,
1 second, sir.
uh,
Uh, uh,
I never used to do in I used to do in Google Meet, but let me this slide share which one?
yeah. Meantime, we will start with an intro.
Yeah, please.
Okay. So, good afternoon, all. So, we got an eminent personality on the sixth day of Adal FTP. So, our personality name is Dr. Srinivasan K. He is an assistant professor in the Department of Forest Resource Management at the College of Forestry, Kerala Agricultural University. In addition to his teaching and research duties, he is also served as an international student coordinator at the College of Forestry. Dr. Srinivasan holds a postgraduate degree in the forestry from the Kerala Agricultural University and further advanced training in sustainable tropical forestry from the University of Wales, UK, and Technische University Dresden, TUD, Germany. His early fascination with the natural environment guided his academic and professional focus toward forestry sciences. His research expertise spans sustainable tropical forest management, remote sensing and geographical information analysis, and a quantitative assessment of natural resources. He has contributed to numerous studies and publications addressing topics such as root dynamics in rubber plantation, soil properties in agroforestry systems, and forest cover monitoring using remote sensing techniques. Dr. Srinivasan actively engaged in academic mentorship and international coordination, fostering global connections and research collaborations in forestry and natural resource management. So, thank you, sir, for accepting our invitation. And we have the audiences from all over the India, from Delhi, UP, Andhra, like almost major states are covering. Everybody is from faculties from engineering colleges and science backgrounds. And over to you, sir. Thank you.
Thank you. Namaskar. Thank you for inviting me for this great opportunity. So, actually, the CV is not fully means I used to do in modeling impact of climate change. Those things I have not included in that. Means I have never updated my curriculum in my website. So, modeling impact of climate change for some disaster management studies and flood susceptibility mapping, landslide susceptibility mapping. All those things are my areas of interest presently. So thank you, Amal, for giving me and Royal Engineering College for giving me this opportunity. Let me start with. I have two presentations to cover, so I will go in rush. First, share it. Hello, Amal sir, this share it. Slide.
No, share ആയിട്ടില്ല. It's
ഒന്നുകൂടെ പറഞ്ഞേ, ഒന്നുകൂടെ ചെയ്ത്. നമുക്ക് മൊത്തം ഡെസ്ക്ടോപ്പിൽ ചെയ്യാൻ പറ്റില്ല അല്ലേ?
there is a green color share button on the bottom.
Yeah, I know. Just I see. It's background. Okay.
Yeah.
So I used to do in Google Meet, so I am not so familiar with Zoom. Okay,
Okay.
so I
Yeah,
hope I will start with just some of the basics. I hope everyone understands what is remote sensing and all.
Yes.
Am I visible?
Yeah, everything is fine, sir. It is visible.
Okay. Okay, so I need to cover I will just tell some of the basics. So what is remote sensing and all? The slide is visible, right?
Yes, it is visible. It is changing.
So Bhaugolik Sujana Pranali and Sudur Samvedan, the remote sensing simply means identifying, observing, measuring objects of interest or areas of interest without being into physical touch. Okay. From far distance, either from terrestrial platforms or from aerial platforms or from the spatial platforms like satellites. So depending on the there are two types of actually mainly classified into two types of remote sensing. One is the optical or the passive kind of remote sensing, in which the sensors use the sun's energy as source of illumination or energy. So you can see from here as the sun source of energy is coming, incident radiation is coming, and the reflected there are some interactions in between according to the type and condition of each biophysical features I mean living as well as non-living, built-up areas, road, natural vegetation, agriculture area, means rocky patches, and whatever be the land use land cover. Uh, land use land cover, according to the type and condition of each biophysical features, it interact with the incidence solar radiation differently. Some will be absorbed. We all know that energy can neither be destroyed nor be created. It will transform from one form to another. So then whatever be the remaining reflected energy is means reflected information is being sensed by the sensor depending on the characteristics of the basic characteristics of the sensor, which is been spatial, which is nothing but its spatial resolution, the resolving power with respect to spatially that can be resolved by the sensor from a far distance. So and then temporal resolutions, how often it revisits the area. You can see from this image, the satellite is orbiting around the Earth. The Earth itself is revolving around the sun. So it is from its orbit, it will revisit the same area. So that is its temporal resolution. And radiometric resolutions, how much quantum levels or the energy levels that can be differentiated by the sensor. That is the radiometric resolutions. And the other one is the spectral resolutions. The spectral, how spectrally how much to what extent the sensor can resolve the information like that. So spectrally, according to spectrally, there are multispectral scanners, hyperspectral scanners, according to different wavelength. From the electromagnetic spectrum, it is used. Thermal remote sensing is there, and then microwave remote sensing is there. In the active remote sensing part, there is nothing like the source as well as the both are the same. From the same platform, it will create its own source of energy, and the backscattered. There it is, backscattered information is being sensed by the sensor. So those are the active and the passive remote sensing component, and you can see that it is been that has been acquired, and then we the analysts, according to whether it is hydrologist, whether it is mining department, whether it is hydrology department, forest department, whichever department means they will use the satellite sensors according to their need and requirement. They will use it, and then with its interpreting ability of the GIS specialist through visual interpretation as well as the means through machine learning models, different models are there. So then it will be finally used for the benefit of the society. In different, we can create different thematic maps out of it. So these are the from gamma to radio waves, the electromagnetic spectrum, the part which is we have been named as visible is the visible part of the spectrum of the human eye. So our eye, we have our own resolution of the spectral resolution. That is only visible spectrum is visible to the human naked eye. The other part of the energy of the electromagnetic spectrum is not visible. That's why we have been named it as visible in the electromagnetic spectrum. So which is nothing but the 400 nanometer to 700 nanometer, and that is in optical remote sensing. And you can see that you can microwave part where you can that part is known as means for used for the active remote sensing. So this is the as I told you earlier. Depending on the type and condition of each biophysical features, it interacts with the incoming solar radiation differently, and whatever is being reflected is being sensed by the sensor. So this is and it is unique to each biophysical features, which is not known as its spectral signature of the any feature, whether it is water body, whether it is soil or agricultural land, or whether it is forest vegetation area. So you can clearly see that here the green is known as the vegetation spectral signature, spectral reflectance curve of the vegetation, and the blue one is for water, and the dotted one is for soil. So according to the interest of that scientist, the soil component, whichever reflectance is high, those part is being used by the soil scientist. as forest resource manager, I am interested in this near NIR region, where you can see that high reflectance from the this thing. Because of that, photosynthesis happens in 400 and blue and red band. We all know that blue and red band, and in that blue and red region, it will absorb, and then immediately after red band, reflectance comes. That is known as NIR band. So that shift, red edge is being used for vegetation indices like normalized difference vegetation indices, in which we've been using that particular spectral signature or spectral reflectance property of vegetation, NIR near infrared minus red by NIR plus red. That is been for differentiating vegetation from other features. So for soil scientists, they can use from 1.7 to that the highest reflectance wherever is coming in mid infrared region, that can be used for the soil scientists. So accordingly, we are interested whatever is reflected, and then so as I mentioned, low for vegetation, low reflectance in MIR and NIR, high reflectance. So that is why we are using that NIR band or that red edge effect beautifully in this normalized difference vegetation index in this. Okay. So those are the basics of remote sensing, the spectral signature. It is different for each biophysical features. Now coming into my today's topic, I just would like to give you some of the applications. Applications of geospatial technology in disaster management. So you can see that from this all disasters from 1900 to 2023, and you can clearly see that in most of the among the floods, flood, drought, earthquake, landslide, wildfire, over the years, flood is dominating recently. You can see that from in our Kerala part, 2018, 19, and throughout North India, what happened. So those flood. So these are the some of the. It is not part of actually today's presentation, but it has been nowadays for prediction part. The climate scientists, climate change scientists used to use this CMIP scenarios. Nowadays it is SSPs. Earlier it was RCP scenarios. Now it is been SSPs. So it is based on the RCPs based on the greenhouse emissions, in terms of carbon dioxide equivalent, and SSPs socioeconomic factors also included. So this is the global warming level. You can see that what happens if there is 1.5 degree increase, what 2 degree increase, 3 degree increase, 4 degree increase, what happens in the overall throughout the globe, what happens. Annual wettest day, how the precipitation increases, how the temperature increases, you can clearly see. And the main of the instability because of this climate change is due to increased temperatures. Rising temperatures can throw permafrost and melt glaciers, increasing slope instability, and extreme precipitation, which has been witnessing throughout, and then sea level rise. So these are the types of floods usually happens nowadays, and it can be categorized into different types of floods, like in common in mountain regions where the slopes are steep and subject to frequency, then it's flash floods, and fluvial or riverine floods as a result of flow exceeding the capacity of the stream channels, and then pluvial or seasonal floods occur with general regularity as a result of major seasonal rainfall activity, and then coastal floods due to tsunami, storm surges, and high winds. Then storm floods experienced in deltaic areas of rivers along the coast, and then urban floods. Nowadays we are really interested in this urban floods and all. So because 70 nearly 50, more than 50 or 60% of the human population is thriving, means living in these urban areas. So nowadays, these urban floods are getting more attention, caused by extreme rainfall coupled with inadequate drainage system, and then snowmelt floods due to the excessive snowmelt caused by the temperature rise and due to the blockage of river caused by the debris, ice and debris jam floods. So those are the different types of floods and impact of climate change on urban floods. Do not happen, as I mentioned, because of this urban heat island. Now I'm on. There is one UHI mapping. The project is being almost completed in by KFDF funding, Kerala Forest Development Fund. So I recently I mapped. It is coming into this by March and April. I will give the report to the KFDF department. All the municipal corporations, all the corporations of Kerala, all the 6 corporations, this Trivandrum, Kollam, Ernakulam, Thrissur, Kannur, Kozhikode, all these corporations being mapped. According to this UHI mapping has been done. Land surface temperature has been compared with this, all those things. So nowadays, these kind of studies are getting more attention. So you can see that the pictures of the China and the New York and the Bangladesh, Bangalore, Mumbai, all those areas in Chennai. Recently, what happened? So nowadays, this Kochi aims to evolve into a sponge city to avoid the flooding. Sponge city is an urban area. See, the more you are going towards nature, I will show you some of the slides. Like there is another slide. It is there, I think. Some swales, berms, and means ponds, retention ponds, all those structures, and green urban space, all those things. So when you do go towards nature, then this kind of issues can be reduced. That I will show you in the coming slides. Okay. So sponge city concept Kochi is aiming, and these are the some of the cities. Also, there are 15 cities at presently trying for this. So this impact of urbanization on land and land use on flooding, you can clearly see that the natural ground in the natural ground cover conditions, what is happening? 25% deep infiltration is happening, only 10% runoff. But you can see on the right side, wherein 75 to 100% impervious surface due to the impervious surface due to the urbanization. Urbanization is happening like in a very high magnitude. So you can clearly see that what happened, 55% runoff is happening in the place of 10% runoff. So those, because nowadays everyone is having the tiled frontage and whatever be the roof, all are made of impervious surfaces. So though there is no scope for drainage, and all the wetlands being converted into what to say, real estate. So there are no space for water to drain or infiltrate. So that happens in the cities. The things are more adverse conditions. So you can clearly see that in the normal condition, pre-development condition, you can, from this graph, you can see that the peak on the x-axis is the time and the flow rate in the y-axis. You can clearly see that because of high unscientific development, post-development, you can see that dotted graph, dotted line, higher peak, because within no time, high peak, it reaches high peak. So this kind of situation is very threatening in densely populated urban areas. So urbanization often results in the construction of impermeable catchments increase in flood peak by order of 1.8 to 8 times. Okay. And flood surcharge by 6 times. It's not. So some of the methods being used. Methods being used means we used to study the flood susceptibility mapping using this AHP method. It has been developed by SATI, which has been widely used for many scientists in different streams, whether it is in biological streams, extension, whichever streams. This AHP has been used for. It is a multi-criteria decision making tool in which whether among the 10 factors which you want to give more priority, like that. So maybe for flooding, the nearness to water, or the drainage density, or the elevation, slope, rainfall, all those things are contributing. Some of the, if suppose some of the factors, we want to give more ranking to them. So AHP developed by the SATI method was the means widely used and acceptable tool in means the multi-criteria decision analysis. So experts assign weights to flood-related factors like elevation, slope, rainfall based on their relative importance, and there is a factor ranking. Each factor is ranked based on the contribution to flood susceptibility, with high values of indicating the greater susceptibility. And finally, the susceptibility mapping, the spatial model combines weighted factors to create a map of flood susceptibility, highlighting the high-risk areas. So another method is the frequency ratio, because based on the historical data of how frequently it happened, are analyzed to determine the frequency of the floods within the different land cover categories. Frequency ratios are calculated indicating the probability of flooding for each in the land cover category in different return periods. Frequency ratios are applied to land cover maps to create flood susceptibility map. The third is machine learning approaches, in which logistic regressions are there, decision tree are there, ANN are there, support vector machine, random forest. So in logistic regression, statistical model predicts the flood susceptibility based on the set of input factors, wherein the decision tree, a tree-based model, identify the rules and the patterns in the data to classify area into flood prone and less prone areas. ANN, the a complex model learns from patterns the data to predict the flood susceptibility. N number of good amount of data has been used. And the support vector machines, a powerful model that separates the flood prone areas from the non-flood prone areas based on the high propane in the data. So compare, if you are going to compare this, this is the pros and the cons. The AHP is considered the subjective expert opinion and easy to implement, and can introduce bias, because we have to go to the experts, different stakeholders. For example, flood, we would like to go to this KSDMA and National Disaster Management Authority, Kerala State Disaster Management Authority, and other NGOs, or Agriculture Department, Forest Department, Irrigation Department, different departments. We are going to, and the stakeholders, local self-government departments. For example, what recently, in wherever the Chalkudi base area or the Angamali, Ernakulam area, recently in 2018-19, what happened? So we used to those LSGD people. So different stakeholders come, and we used to make a kind of either the different methods of questionnaire, or questionnaire. We can use questionnaires, or we can make local group discussions through discussions, and from subject experts, the scientific community, you can get the inputs, which factors contributes more or contributed more to that flood at that particular region at that particular time, and what was the reason, sole reason. So accordingly, we finalize the means we finalize the ranking of the factors, and then finally we will do the weighted overlay analysis. And frequency ratio, relatively simple, relies on the historical flood data, as I already mentioned, requires extensive flood data, sensitive to data quality. And the machine learning, in the case of machine learning, it handles complex data patterns with high accuracy potential. And it has been a huge amount of data is being used and analyzed with suitable workstation kind of that much processors, and requirement is there, requires significant computational resources, and may overfit the training data. So in my some of the case studies, HP method. Amal sir, it's visible now. Okay. Hello. Hello.
Yes, sir. It is visible.
Okay. Case study one means susceptibility mapping of the Kozhikode district via geospatial techniques to delineate the flood susceptible zones using this HP method. And here the data sets, spatial data sets, as I told you, using this remotely sensed data sets from different spatial platforms, which has been used for the study, and SRTM done, digital elevation model, Giovanni data, meteorological data sets, and then the Sentinel-2, which has been by European Space Agency's 10 meter with 10 meter resolutions being used as the spatial data sets. From the DEM data, we have derived the slope, elevation, distance from river, drainage, density, and topographical wetness index. From Giovanni, we have used rainfall data, especially of those 18-19 period. And then Sentinel-2 we have been used for land use land cover class. So this is a minimum number of factors. The more the number of factors, as per the AHP from the subject experts and different stakeholders you can incorporate, the better map or the susceptibility map can be generated. This is just for a case study. Some of the important factors being taken from different research articles. So this is that kind of study. So the more the number of factors contributing, so maybe this may not be the same situation in a Wayanad region. This may not be the same in the southern region of Kerala. So according to the region, locality, and the intensity of floods and the rainfall pattern, all those different factors, uh, the output will be different. Okay, so accordingly, HP calculation is done, and finally weighted overlay analysis has been done for, and flood susceptibility map is being prepared. And then you can see that all the factors, slope, elevation, distance, we have created reclassified maps for each. Reclassified distance from river, reclassified slope map, drainage density map, TWI map, and rainfall map, LULC map, elevation map. And then this is the, I told you, through HP and all, the which factors to be given equal importance, moderate importance, strong importance. Likewise, we used to rank and all. Then the weightage of the factors. From in this case, we have came to a conclusion that TWI is having 21, elevation is contributing 12%, and the rainfall distance from river is the more nearest to river, the more chance. That's why distance to river is 20%. And the drainage density is also related to this river, so that is also contributing more. So 22, 20, and all these 21 TWA also depending on this river, the closeness to river and all. So nearly 60% is contributing to that aspect only. And then the result is like this. So the area of the flood susceptibility map has been grouped into 5 classes: very low chance, very low, and low, moderate, high, and very high risk. So most of the very high susceptibility area in the western side, that is near the coastal region. So in my some of my friends who accompanied me in this study and substantiated that this happened. This was actually happened in those areas. So this is the, for validation we have been used the flood inundated area during 18 as from the Kerala floods, as well as the Kerala state disaster management plan, disaster management maps. The another this thing mapping of the Alapura district via HT, the same kind of method. Here also the same number of factors been used, and then we got a very good. These are the different reclassified maps of each factor, and then finally through AHP calculator, we have been given the priority, and then finally we came to this weightage of factors, and here elevation contributed more, and then slope, then distance from river, then drainage. So in each case, earlier in Kozhikode it was different, and here in this particular area it was different. So because we know Kutanad and all, almost during floods and all, it will be always underwater. So elevation is an important factor there in Alappuzha. So according to the locality and all, it is the our weightage will be different, and the output will be okay. Both the northern and the southern region are showing high risk of flood susceptibility. And this guy made a very good poster out of it, and it got the best poster award of this Alappuzha district, and it was validated also. Done by comparing the fine map with the flood prone areas and by NCES. Then low impact. So some of the this is what I told you earlier: the detention ponds, the porous pavements, the some gravels or the metals only. If you can incorporate without tile in front of your homes and all, you can if you just raw metal, no, that will be good for drainage, or this kind of porous pavements if you can create, or the grass swales. Swale is nothing but a sunken kind of with grassy surface, and berm is the opposite, with a convex shape. So infiltration trench and rain garden, green roof, those are the some of the low impact designs. Refers to approach the land development that work with nature. The more you go towards nature, the impact of these kind of disasters will be reduced to great extent. To manage the stormwater to close to its source as possible, infiltrating it will these are the LID, what LID do for you: infiltrating, filtering, storing, and all. So it will reduce the impervious surface. That's the main thing, so that the runoff will be reduced. The managing runoff and rate duration improves the water quality, mimicking the nature, and reduces the pollution. So these are some of the studies been throughout the around the world, in which Atal in China, detention pond, nearly 92% reduction in the peak in flow rate. And for example, in Colorado, USA, according to Treadway and Havlick, the stream naturalization and rain garden reduction of runoff by 18 to 18.8%. So, and then Ahmed Atal infiltration trench in Malaysia, going back, this kind of LID can reduce peak flow. So according to the different kind of localities, the terrain topography and all, latitude, longitude, the kind of different kind of LIDs can be implemented to reduce the effect of flooding. So you can just see in 1 to 19 August 18, you can clearly see that the normal rainfall is 287.6, and the actual rainfall happened was 758.6 millimeter. So the deviation from the normal is 164%. So this is according to the KSDB. That's why that much great disaster happened to Kerala. Okay, so this is the what happened on those 18, according to the KSDMA, in which areas the flood and landslides happened. On the right side, you can see that the landslides, that red dots, no, these are the were in Idukki and all, Idukki region, and mainly some part of Thrissur. Okay, then Wayanad region, you can see that, and some northern side of northeastern side of this Kannur part. Okay, so you can see that clearly this landslide was really concentrated more on this Idukki region, Idukki as well as Pathanamthitta, some area. Okay, Kottayam, some part. Okay, so this is the on the left side. This is the flood. What happened all those time during this flood affected areas in Kerala. So as we already we mentioned, it's a heuristic method, and we have prioritized based on the contribution to the. Before going to the landslide, I just want to. Okay, before going to landslide, I just want to show you. Some of the factors influencing the natural disasters, from this pool we are usually taking the depending on your interest, you are taking parameters, and you are downloading these geospatial data sets, and used for different methods like AHP, frequency ratios, or whatever, and then machine learning methods and all. So topographic factors, elevation, slope, aspect, curvature, relief, and geomorphology. Transportation related factors, distance and density of roads and railways. The more nearness to the roads and this thing, the casualty or the mortality will be more, because the so it should be also taken into consideration. Soil related factors, soil type and thickness, hydrological factors like distance and the distance from and density of river, stream and drainage, topographic wetness index, stream power index and rainfall, geological factors like lithology, distance and density from fault and lineament, all those factors, land use, land cover, okay, plantation, barren land, all those things. So those are the factors contributing. And then see, you can clearly see that there are different types of landslides. Okay, fall, topple, slide, rotational as well as translational. So according to the different types of material, bedrock, predominantly coarse material, predominantly fine material, rock falls, debris fall, earth fall, like that. Okay, according to Highland and Johnson, you can clearly see that. Amal, the slide is visible, right?
Yes, sir. It is
Yeah.
visible.
Yeah, rotational landslides. Ground rotates and the slides along a curved plane. Okay, what happens? It's known as rotational, and you can clearly see that what is kind of from the picture itself. You can clearly see that what happens.
Sir, this slide is not visible.
ഇത് കാണുന്നില്ലേ?
ഇല്ലില്ല.
ട്രാൻസ്ലേഷൻ ഈ സ്ലൈഡ് കാണുന്നില്ല.
ഇല്ല ഇല്ല.
അയ്യോ, അപ്പൊ ഞാൻ തൊട്ടു മുമ്പ് പറഞ്ഞതും കണ്ടിട്ടുണ്ടാവില്ല അല്ലെ?
സ്റ്റാറ്റിസ്റ്റിക്കൽ പോർഷൻ കണ്ടിരുന്നു. ഓക്കെ,
ഇപ്പൊ കാണുന്നു സാർ അത്?
യെസ് യെസ്.
ഇപ്പൊ നമ്മള് ഗൂഗിളിൽ നമ്മള് സ്ലൈഡ് മൊത്തം ഡെസ്ക്ടോപ്പ് അങ്ങ് ഷെയർ ചെയ്യുമ്പോഴേ മൊത്തം കാണാറുണ്ടായിരുന്നു. So here നേരത്തെ പറഞ്ഞ ഈ സംഭവം കണ്ടില്ല.
ക്ലാസിഫിക്കേഷൻ ഓഫ് ലാൻഡ് സ്ലൈഡ്സ് തൊട്ടിട്ടാണെങ്കിൽ
ഫാക്ടേഴ്സ് ഇൻഫ്ലുവൻസിങ് നാച്ചുറൽ ഡിസാസ്റ്റർ കണ്ടില്ല?
അത് കണ്ടിരുന്നു.
ഓക്കെ ഓക്കെ ഓക്കെ. So accordingly, different the landslides are classified differently according to the type of material, bedrock, predominantly coarse or predominantly fine, and depending on the movement, type of movement. One is type of material, one is type of movement. Bedrock, predominantly coarse and predominantly fine, and then the type of movement, fall, topple, slide, lateral spread, flow. And that too, rotational or translational. So accordingly, you can clearly see that rotational landslide, ground rotates and slides along a curved failure plane. Okay. And then translational landslide, ground slides with little rotation along a flat plane parallel to the surface. And what happens in rock fault as well as toppling and earth flow. Okay. Then lateral spread when the surface material extends or spreads on gentle slopes. Okay. Then debris flow, and then debris avalanche, creep. So these are the different types of landslides. So accordingly, we will use, as I earlier mentioned, no, the different factors depending on this type of material and this thing. From these factors influencing natural disasters, the topographic factors like elevation, slope, aspect, curvature, transportation related factors, the soil related factors, land use and cover, geological factors, hydrological, all those things we used to take. We will take for the AHP or the machine learning methods to analyze the susceptibility mapping of landslides. Okay. So here, just for this mapping, Nelambur area, you can clearly see that the spatial data sets we used for this particular study was allows pulsar, DEM, allows pulsar DEM, as well as it's an active remote sensing synthetic aperture radar platform. So digital elevation model, then Geo and Giovanni, and then the Sentinel data sets. So from the DEM data, we have been, as in earlier flood mapping also, slope, elevation, distance from river, rainfall, all those been taken, and Sentinel-2 lineaments, land use, land cover, and soil texture. Then soil texture was taken from the ISRIC grid data, and then non-spatial data was the transport network. And the ranking method, MCDA, multi-criteria decision analysis, were in the ranking method, rating method, and AHP. And then the landslide zones were mapped in the Nelambur region in one of the case study. You can clearly see that in the different factors, each factors like slope, elevation, distance from river, all those things. You can clearly see that the slope map, the rainfall IDW and land use land cover, and the digital elevation map, and the transportation network, landslide lineaments, soil texture, distance from river. So I'm not meaning to say that these are the minimum factors. The more the number of the factors according to your type, according to the locality or the nature of occurrence of this particular disaster in a particular region. See the way in which the landslides are happening in the Himalayan, subtropical Himalayas or Himalayas, or the Western Ghats, all are different. I mean, the pattern is different. The see the factors also influencing is different. So unscientific, see, because of the unscientific land use land cover change happened over these years. Okay, you are removing the deep rooted trees from the hills and planting cash crops which are shallow rooted, and the roots cannot hold the soil, and it will topple. So that is the those earlier in those earlier times, where there was very good forest or vegetation. It has been large scale, in large scale it has been converted into inhabitation through encroachments, some patayams, all those things, and then unscientific removal, removing the deep rooted trees and planting the cash crops which are being shallow rooted, all those things. Those are the one of the so accordingly it will change according to the in the northeastern part of India. It will be different facts. Some the general factors are same. See the elevation or the slope, all those things. Those are same, but the slope, elevation, or rainfall, those are same. But some more factors will be more contributing in particular region. So those factors also you need to incorporate through AHP that I told you. You have to go through different stakeholders, through scientists, and get the information from them which factors contributed to that particular disaster, like that. Okay, so the better the more the number of the factors, the more will be the, and then the finally this to by this HP method and ranking, you are giving weightage. So in that study particularly, slope was the more contributing for that slopy regions. So 24% was given weightage to that slope factor, and then 21 also given for rainfall, and then 18% for the land use land cover change happened. So overall, those were the more than 60 or 60, and then from among this 100%, and then finally what happened? In rating method it was done, and then HP method, this was the here also the slope was 35 and rainfall 20, the same. So accordingly what happened, we have done the weighted overlay analysis, and vulnerable zones of Nilambur Taluk, Malappuram district was made using ranking, rating and HP methods, and the HP method was this HP method was the validated one. Okay. Then high resolution landslide sensitivity mapping using the ensemble machine learning and geospatial data sets. See, nearly it is an older literature. Actually, it's more than that. 1,05,224 landslide polygons and 49,105 landslide points from Geological Survey of India. Cooler database landslide 489 points are the models used to support, as I earlier mentioned, no machine learning methods, SVM, artificial neural network, random forest and ensemble model has been used for high resolution landslide susceptibility mapping using machine learning methods. Okay, so this is India's landslide susceptibility map, inventory of this thing, wherein you can clearly see that very high regions, very high risk areas are located in the Himalayas, Himachal Pradesh, Jammu regions, and Uttarakhand. You can clearly see that Uttarakhand region. And this year itself, we could clearly see that. No, last year we could clearly see that how many landslide happened on that Uttarakhand as well as Himachal Pradesh region. Then Sikkim part. Recently, you came to know that we came to know that large this thing Darjeeling part and region and all landslide happened. So, and the northeastern parts and in the Western Ghats, we are non exceptions. In Western Ghat part also there is but it's compared to northeastern as well as the Himalayan regions. I told you the elevation, the slope, all those factors contributes the more in this kind of landslides and also. Then landslide in inventory map, India also telling the same picture. In digital deep neural network, this you can see that in 3,575 events happened. Okay, and out of that, for testing, we have given 1,072, and training. It is not my work. It's been literature. I have not done this deep neural network kind of studies. So from this also, you can clearly see that in Kerala, from 2017 to ecologically sensitive zones, how much areas changed to see this part of Idiki happened. Okay, highly sensitive. See in this map, you can clearly see that newly added ecological sensitive zones in percentage. In Idiki, the red one, means drastic increase happened over these years. Even the Palakkad region. Okay. So some of the what to say, we cannot mitigation measures kind of thing can be like wired mesh, a kind of concrete, proper scientific concrete walls, geotextiles on this the slopes, over the slopes, retaining walls creation, and the terrace farming, and this anchored mesh systems like using wire rope, base plate, and steel and all. So those are the some of the in the slope areas that you can do to reduce the impact of landslides over these. See, this is another part of this thing application. Before I go to this slide, I just would like to invite you this Yeah. Some of the applications. Amal, it is visible, na?
Yes, sir, it is visible.
So before going to that, I just would like to give you the application of uh, remote sensing or geospatial technology in the natural resource management in monitoring the forest cover change, forest burnt areas, pest disease, stress occurrence, and with respect to crop inventory, the forest type identification, species differentiation, with respect to the watershed management, the characterization, prioritization, development and monitoring, and with the soil resource inventory, assessment of soil related constraints, land evaluation, and with respect to the water availability, monitoring surface water bodies and groundwater exploration, and the land degradation, extent of wastelands, all those things, damage assessment, as we already mentioned, wildlife management, how to map the animal conflicted areas, and what are the probable reasons. There also you can do this kind of multi-criteria decision analysis methods like machine learning as well as this HP tools to reduce the impact of this, reduce the animal conflict, or the at least you can try to reduce to some extent. In habitat assessment, census for big animals tracking, all those things can be done. These are the applications. Then we are going to that application of active remote sensing component in the forest resource management, wherein the different indices, as we already, let me one second. Indices like normalized difference vegetation index, leaf chlorophyll index, normalized difference red edge index. I told you that red edge just near beside just Vibgeo, no, the visible band is the white indigo, green, yellow, violet indigo, blue, green, yellow, orange, red. Just immediately after this red, near infrared happens. No, the near infrared is there. So that normalize to make use of that. This normalized difference red edge index, green normalized difference vegetation index, normalized difference water index, and then normalized difference moisture index. And in moisture index and all, SWIR band, short wave infrared band, and NIR band is being used. In normalized difference water index, green and NIR band is being used because there you can clearly differentiate the water. And then normalized, so according to the particular what to say, spectral response of each uh, biophysical feature, as I already mentioned earlier, according to the spectral reflectance pattern of each biophysical feature, we've been using different indices. Other than this normalized difference built up in the built up index is there, so many indices are there. So according to that our use, we are using these bands, and in raster calculator we've been using adding and dividing different bands, and then we will get some indices which is being which used to get which we will use ultimately to differentiate the feature of your interest, like for vegetation for us NDVI or the advanced vegetation index, that also can be used. The leaf chlorophyll index is also vegetation kind of differentiating kind of indices. So accordingly we will use, okay, different and water index, okay, moisture index, if we have soil moisture index, okay. So these are the different maps of that particular study region, and you can see that regression equation model for above ground biomass for moist distress forests with backscatters. I told you active remote sensing case, you will never say that reflected information. It is the backscattering because the source and the energy is the same, are sent from the same platform. In the case of passive remote sensing, the source is different and the sensing is the receiving and is the sensor. Here it is the same. So the backscatters information. So different MLR models, multi-regression models are developed for the different canopy density classes using the synthetic aperture radar data. So for very dense forests, you can see that regression equation model, and the moderate dense for another equation, open forest. So where this X, in all these equations, you can see this X and Y, wherein this X is the backscatter value for the VV polarization and X1 is the backscatter value for VH polarization. And Y is predicted above the above ground biomass. Y is the ultimate output we want. And in the case of passive, and this is the backscatter image of VV and VH polarization of MDF Mungod. And then this for the passive data sets, this is the canopy density classes. For each these canopy density classes, these the equation is different, wherein the Y is your predicted above ground biomass, and X is nothing but your NDVA value. I told you this, it is directly proportional to your vegetation canopy. No, canopy will be directly proportional to the tree canopy will be directly proportional to the vegetation indices. So that NDVI value is being used in this equation for predicting the above ground biomass. So that is the R square value. See, you can see that R square value for each equation is very high. Okay. In the last case also, with SAR data is not so good with R square value and all. Okay. Then these are the NDVI values for different classes. It varies from -1 to 1 now. So these are the different NDVI classes for water bodies, settlement, agricultural land, horticultural land, open forest, moderate. If it is 100%, then the NDVI value will be 1. If it is very less, then it will go to minus also. Okay. You can see that in water bodies and all, settlement and all, settlement area and all, normalized difference vegetation index is minus. There is no vegetation. So it is NDVI map of Mundangot. So for different machine learning algorithms use random forest predicted above ground biomass, KNN predicted, SPM predicted, GPM predicted, ML. So the different spatial distribution predicted above ground biomass, different machine learning models in that study. So I just would like to say that machine learning approach is being widely used nowadays for in this kind of studies. Okay, in above ground biomass, forest fire. The another case studies, as I told you in the earlier slide, the fire monitoring is a very the fire threat, especially in the summer time in the forest. We used to hear in USA and all what the fire is doing in particular summer seasons and all. And here also there is no difference. There are man-made fire, and we know that there is a triangle, fire triangle. Source is there, oxygen is there, and there should be fuel load also. If you can cut anything, any one of this the component in the triangle, either the fuel load or the air or the source, you can prevent the fire. So in forest resource persons and all, they used to create fire lines and all to prevent this fire this thing. So forest fire destruction and forest fire susceptibility mapping of Kottayam Forest Division. So recently once in one study. See here also. See, I told you there are different indices. Here the normalized burn ratio is being used, and DNBR, difference between the pre-NBR and post-NBR is being so forest fire easily. So according to your interest, there can be, we can use this reflectance, the spectral band, and you can make use of very good indices for your particular study and get into it. Okay, the methodology is nothing but the lands. One is the Landsat the satellite data component, and the accuracy assessment through the actual fire points. Okay, so pre-NDVI, post-NDVI, and differential NDVI can be taken. See, prior to the occurrence of the event, fire, post normal. See, pre-NDVI means vegetation whatever existing prior to the fire. The post-NDVI, after the fire, the vegetation gone. So you can compare this DNDVI and you will get a clear idea. Now, other than that, normalized burn ratio, NBR, posted NBR, then forest fire detection from that you can get. So for this factors affecting this forest fire and all, we have taken Sentinel-2 data for land use land cover, satellite data DEM for elevation slope aspect, meteorological data for temperature, rainfall, wind speed, because wind is also a very good contributing factor for this fire spread. The ground fire, different fires are there. So accordingly, here also I told you this, here the HP is being used, the HP technique is being used in different contexts. Earlier for landslide disaster or the disaster management aspects, here also it's a kind of disaster, but there are man-made disasters and there are natural disasters. Natural fire also is a kind of disaster. So we are using this kind of HP or heuristic method, as well as the even machine learning methods. If you are using HP method, then you are doing this weighted overlay analysis, and finally you can create the forest fire susceptibility map. So here the calculation of the weightage, as I told you, HP calculator is there nowadays. And through this questionnaire surveys and focal group discussions, FGD surveys, and different methods, you can get from the scientific inputs, from the scientific articles, from the government authority, national disaster management authority, different authority. You can get which factor contributed to here. This is what I meant. See, I told you, no, giving equal importance. If you are giving same importance for land use, land cover, and elevation, you will give 1. If you are giving land use over elevation, then 2. So how much more giving importance? For example, land use over rainfall, 9. See, this is for this is for which fire it is. Yeah, likewise we are doing for any event, like for landslides, for fire, for this thing, flood. You are comparing in HP calculator like this, like how much we should give more importance to elevation over land use land cover, how much we should give more importance to aspect over elevation, how much we should give how much weightage means importance should be given to over temperature to slope, like that. According to your HP and all, you will this is what you do. And finally, on the right side, you can clearly see, get the priority of priority accordingly from the HP calculator, and then which is being used for the weighted overlay analysis. And you can clearly get this kind of in the case, this is the fire case study. That's why whatever be the land use, land cover, elevation, slope, aspect, temperature, all those reclassified maps will be there. Reclassified map of the forest division, Kottayam forest division, land use, land cover map, elevation map, aspect map, likewise slope map, temperature map, wind speed map, all those things. And this wind speed and rainfall temperature are getting from the Giovanni or the MD datasets. Okay. Then hello, sir.
Sir, you can continue. It's a noise. I will mute it.
Okay, sir. Okay. Then the forest, you can fairly get the forest fire susceptibility map of the Kottayam forest division. This is the jurisdictional area of the entire Kottayam forest division, territorial division, where you can see some of the where in the green, see that low impact areas, for low prone areas is there, but the forested vegetation areas, no, highly this wherever this deciduous forest, most deciduous forest, you can clearly see that it is a high risk zone. You can see that in the entire forest division. And there are mainly in this forest division, it is not highly prone to forest fire, but still 30 to 35% of the forest division is prone to see. And when we overlaid the fire occurrence data, you can see on the right side. See, this is the classified map, and what you can clearly see that on the inventory data, no, whatever the fire occurred data, it is clearly overlaying with this the map. But we see, I told you, the more number of factors you can include, the more better map will be there. But still, we be used different factors, which is been through scientific articles, research articles, and through the discussion, focal group discussion with the department, forest department, agriculture department. So what we generated, the map was, when we overlaid the fire points, you can clearly see these dots. See, these all are the fire occurred areas. So it is classifying correctly. Northeast part of the study area shows high chance of forest fire. Majority of the area comes under the low risk zone. Okay. Then another case study. This is kind of a wildlife or the species suitability mapping. Okay. So according we all, including the Homo sapiens, we prefer a particular kind of, we prefer plain areas, or usually prefer more for habitation we have used to the plain areas. And uh, some pahadis are there throughout the India. They prefer hilly regions, but most of the people are preferring likewise, and that too near the water source, near the sea, coastal regions. That's why you can see that in most of the cities are concentrated near the coastal region, Mumbai, Chennai, or Calcutta, or throughout the wherever this near the water bodies or the river Thames, all those things. So water source. So accordingly, so one is the demand for the natural resource of that particular species. Okay, so Buxus Valiachiana, for its particular soil, it will prefer one particular type of soil. Okay, so the soil pH, all those things. Okay, different factors are contributing. No, I mean to say that for any suitability mapping for any particular species, including Homo sapiens, there are a trend. There are we know that in which areas those species, whether it is lion-tailed macaque, whether it is tiger, whatever be the species, or the langurs, whichever species, were the plant species. Okay, the preference, you can see that there is a different trend. See, in forest types, you can clearly see that there are ecological classification, and we in India we used to follow Champion and Seth, Harry G. Champion and HK Seth classification of forest soils, forest types. So we have 5 major groups of forest type, major groups, and 14 types of forest classifications. So like tropical wet evergreen to semi-evergreen, moist deciduous forest, littoral and swamp forest, dry evergreen forest, then alpine forest, subalpine, like that. So all these different types of forests are have the climax forest, depending on the climatic as well as atmospheric, means I mean to say that the temperature, the rainfall, the moisture requirement, okay, the topography and terrain. Ecology is a combination of all these things. No, at what elevation, at what kind of terrain, at what kind of temperature. Also, the higher the temperature, higher the altitude, lower the temperature. So, and some species will prefer the high, so alpine, subalpine, alpine. Okay, so mountain, subtropical, tropical forests. So different types of forests according to this kind of latitude and longitude, as well as the this kind of altitude, topographic, as well as climate. Climatic means the temperature requirement as well as the rainfall. So we know that there's a definite trend of particular species, and then we can clearly predict in these, if these are the conditions this particular species is preferring, what will be what is the chance of this particular species in other region of the same kind of same kind of climatic as well as environmental requirements, the human resource, whatever with the resources. Okay, so then you can clearly use this habitat suitability mapping for different species, not only for Buxus valenciana and all. So different types of soils are there, and which you can clearly see that in suitability of that particular species. So these are the different applications of geospatial technology. This is for forest canopy density. One of my student recently completed his study, in which wherein he has last time he has given one presentation also to this engineering college, and forest canopy density study happened. And we've been using this Landsat operational land imager and linear image self scanner 3 for getting canopy shadow index. From the name itself, you can clearly see that. Canopy density means what? The canopy, tree canopy, no? Forest with canopy. So we presume that wherever the canopy is good, there is a very healthy forest. So canopy, it is very, this forest areas, you know that in India, 1/3 area is under forest, but most of the Western Ghats, northeastern India, and subtropical and tropical Himalayas and all, the forests are in very, very high hilly terrain. It is very difficult to reach each and every corner of this forest area. Some are extremely difficult. Some in some areas you cannot get even the correct satellite picture also. Even the Silent Valley, all those, the deep forest. Okay, so what in general we can say that from this application of the spatial technology, geospatial technology, we can use this information of this uh, forest canopy, okay, or the density. So canopy density is an indirect measurement of the tree health, forest health. So forest canopy density is an indirect measurement of the forest health. So if you can create a forest canopy density model using geospatial technology, I can clearly say that this kind of this parcel of area is having a good kind of strong means healthy forest. This area is weak. This area is encroached. This area is so in Kerala and all. No, there is another difficulty is also there. This rubber also comes into this picture. Tree outside forest. This rubber, the other cash crops. No, it will the reflectance of these vegetations is so high degree of ground truthing is required to differentiate this rubber to remove the rubber component and other cash crops from the palm trees and all from the tree vegetation, the real forest vegetation. So that then only you can clearly map the forest survey of India. What happens now? Every time they're over exaggerating the forest area of Kerala. Actually, this much forest is not there, but still this they are getting through the satellite data now. So they are the ground truthing is not that, but in India overall that is the best source. There is no doubt. But when you are going to individual districts and all those things, you can clearly say that misclassification has happened because of this in Kottayam and all those areas, Palar, all those regions. This rubber comes into or all those misclassification happened as forest. Okay, so where you can clearly see the shadow effect. See in visual interpretation of elements, no, you can you are identifying an image using this tone, texture, color, structure, shadow, altitude, structure, pattern, all those things. So this canopy shadow you can use for getting this canopy. Advanced vegetation index, I told you AVI, vegetation different indices can be taken. Then bare soil. The bare soil is more, less forest canopy. The bare soil is less, more forest canopy. So that is why, and from that forest canopy density is made, and then canopy accuracy assessment is done. We have a densitometer kind of instrument where you can clearly say that how much canopy is open or this thing, and then otherwise or else also you can make a 20 meter plot and you can clearly draw the area, means the mark the area of the tree under the tree crown and the bare soil. That also is another possibility. And then finally you will get the forest canopy density map. On the right side is nothing but the normal procedure for the forest land use and cover. So advanced vegetation index is using red and near infrared and spectral in the among the spectral bands. Bare soil index is using shortwave infrared and an AR band. Canopy shadow index is using important for the analyzing canopy cover based on the shadow information in the imagery. And the VDI, vegetation density index, represents the proportion of the vegetation density calculated in the relation to the soil index. And SSI shadow soil index also is taken. So these are the different indices being used for this forest canopy density, and that is another application. And this is it's not complete. If I am having time, I have something more to complete from the earlier presentation. Can I do that?
Sir, it's 3:30.
Okay. Then okay. So these are the some of the platforms you can get. IRS, ISRO, Indian Institute of Remote Sensing website offers free online. I am also an IRS outreach program coordinator for this KU. Likewise, in every institute, they can start their own IRS outreach program. So nowadays, more than nearly 3,000 or 3,000 or more than 4,000 up to institutes. We Indian Institute of Remote Sensing, അല്ലെങ്കിൽ ISRO is being the biggest giant in the Southeast Asia or the among the SAARC countries. So we've been giving training to all these countries. NASA, ARSNet, Rcet, Applied Remote Sensing and Training, provides free practical webinars, and ESA, European Space Agency, Coursera is there, Open Learn, Future Learn, JS Geography. These are the some of the website, and then these are the some of the data browsing websites: Earth Explorer, NRC, Space Imaging, Digital Globe, Spot Image, Copernicus. I told you, no, this Sentinel. It has been you can avail it from Copernicus and the USGS, thematic mapper, oil live, all those things. Okay. So actually, my presentation was uh, given in two. So this one is completed from that other slide also, right? This is now visible now.
No, the new slide is not visible. I think, sir, we can go for the Q&A.
Yeah. Please, please, sir. Okay.
Anyway, few minutes only left because it's already 3:30.
Okay, sir. Okay.
So I'll be representing everybody, and I will be giving a few doubts which what I felt during the session. For example, in this Kerala, basically in Kerala, we have very high rainfall, but we have I felt very comparatively small river basins. So, how does this kind of unique hydrology challenge our conventional flood risk compared to other part of India? This is kind of our unique hydrology in Kerala.
See, I told you, this nearness to river, near the Chalakudi or Periyar, all those areas, the susceptibility is more. It is. I can show you one picture. This slide is visible.
No. I think, sir, we have to close the previous PPT, then reshare the new PPT. Sir, also recently any...
Just 1 second.
Yeah.
Now is it visible?
Statistical method.
Okay.
It is visible.
It is landslide only. See, no, I mean, in recently one flood susceptibility mapping using HECRAS and HMS happened for done for one of my student, and it was exactly that Adrapalli, that region. No, the downstreams all were flooded. Means the and we've been validated using this 2018-19 data sets or the spatial as well as the field data. Then we could clearly see that nearness to your question was the watershed of Kerala.
Yes, yes.
What is the unique in all across the your main question was? It was
Like we have very small river basins and all, and we have very high rainfall. So this kind of unique hydrology,
see the thing
how?
is though no the thing is see or the why with this fatality the casualty is more because the mortality is getting more no or the we are
Mm,
densely populated and
yes,
in most of the because of the densely populated condition we've been uh, means deployed. The settlements are deployed nearby the rivers as well, the nearby the whatever be the river streams. Okay, means near the river streams and by convention itself, we've been Homo sapiens been preferring this water nearby the water source. So
yes,
and in Kerala, as the land is scarce and most of the populations and the cities like the Cochin or the whichever the you can clearly see that in this flood inundated area. This slide map is showing, na?
yes, sir.
You can this is Kerala floods. You can clearly see. Uh, you can clearly see that
Yes,
see in the coastal areas. See these the on the right side you can see na on the right side this Idiki Pathanamthitta regions.
yes, yes, yes.
See these are the hilly means the high elevation is more and Idiki and all highest peaks are there. So this towards downstreams what happens no see in Alapi, Ernakulam part, the Thrissur part, all those things towards this region, this flood happened. The Chalakudi as well as Sangamali, all those areas. It is in everywhere. It is the trend is like this only. In wherever the ultimate impact will be in the low lying areas. Ultimate impact the
Mm,
landslide and all those things happens in the upstreams and the ultimate the cumulative effect will be in the down and that's and unfortunately in those coastal regions the high density of population is there because of the inhabitation pattern of the means human population especially in the cities Ernakulam, Cochin, Trish, wherever the Kozhikode, all those things in Kozhikode and all there is not much flood as per the
mm,
2018 but in this
yes.
2018 this you can clearly see a very good trend in this Adrapalli, Thrissur area as well as this Periyar.
Sir, actually, what I felt is like in Kerala, there is a very high literacy rate and there is a high scope of digital penetration. So, can we have any community level, uh, like crowdsourcing kind of some approach and or to improve our disaster management model using any mobile apps or something? Any such a project is going on?
Yeah. In national, see now, I exactly I don't recall, but there is PM Modi's PM's 10-point agenda like that. Something is there nowadays.
Mm,
Recently I forgot, unfortunately, sorry. You can check the disaster management NDMA side. It is clearly mentioned the 10-point goals nowadays. Climate the resilience is more coming into the picture. Resilience, there is no way the whatever be the hazards is happening either through man-made or either natural or man-made. Man-made, why I'm telling is man-made is because of the unscientific management, unscientific kind of creation of the urban areas. Okay, by overtaking the what to say the sponge, the what to say the natural ponds or the you can see that in most of the Cochin, most of the Thrissur areas, a lot of wetlands means the padam, Nel padam is been paddy fields been converted into. That's why this Wetland Act came now in 2018, 2008. And so
mm.
that much area has been converted. and there is no rules for, and it has been converted by the real mafia to means real estate mafia into this kind of. So that is why, and in most of the cities, there is no room for the drainage because of this uh, impermeable some,
Yes, sir.
yeah.
Sir, actually, one doubt came. If we make a application which can,
Let me come to a question. This app is there. There is a uh, in during one of my training, it was given according to this Prime Minister's goal, as well as this nowadays resilience. No, the awareness
Hmm.
program. How
Yes, yes.
we can give so much awareness to these people. See, recently we've been using this geospatial technology, and this whatever be the disaster management authorities are giving proper alarms. Means what to say, to the local self-government bodies, and the local self-government bodies along with the police and all other protective fire department, all those, they are acting really well to rehabilitate them. That's why nowadays the casualties getting lesser.
Mm-hmm.
Otherwise, this Choramala or kind of thing will destroy like anything. The number will go.
Mm. Yes.
So yeah. So as you said, there are very good number of app. I unfortunately I there are apps of disaster this and citizen this thing, no. As you saw, as you told, the crowdsourcing is there. So that in you may be knowing what happened in Uttarakhand in what to say, that Shiva temple, Kedarnath,
Kedarnath,
yeah,
yes.
Kedarnath flood. No, after that, there are a good number of applications are there for giving this kind of awareness to this. There are, it is there.
Okay, okay, sir.
Yeah,
So I think our time also it's a little bit in a limit. I think no further questions. I believe in the chat and there is no much questions. So I think let's conclude, sir. And it was a very interesting session because nowadays this kind of disasters and all it is keep on happening, especially the flood and all repeated floods. I think 2018, 19, and 21. So and it having a very different kind of impact patterns also. So I think in future if we can work on this kind of models, especially deep learning models and all, which is trained on the past Kerala floods
Amal,
and
one, can I tell you this thing?
oh,
The
application
Prime
name.
Minister's 10-point agenda on disaster risk reduction. Okay.
Okay.
This 10-point agenda on disaster introduced in 2016 aims to mainstream risk reduction into development, ensure universal risk coverage, boost women's leadership, and leverage technology for building resilient. I told you, no, nowadays
Yes.
resilience is the term. Not
Mm-hmm.
you cannot stop it, but it is we have to adapt and resilient infrastructure, and it emphasizes local capacity, knowledge sharing, as you said, and learning from the past disasters. The 10-point agenda are the mainstream DRR and development, risk coverage for all, women's leadership, invest in risk mapping, leverage technology, university network, social media and technology, local capacity building. Learn in that case, your this thing will come. Crowdsourcing and
Okay. Okay.
learn from disasters and international cohesion. So these are the 10-point agenda. So and in the giving disaster risk, we cannot remove it. Disaster, we can reduce the risk
Okay.
disasters. That is what Prime Minister's
Prime
thing.
Minister's.
Yeah. So yeah, please continue. Thank you. Thank you.
Okay. So thank you, sir. And we will be sharing the presentation. And that can you please share the link, sir, to me or in the chat so we can that 10-point agenda. So participants also will be able to read.
Just Google, yeah, just
Oh,
Google.
it is available in. Okay.
Yeah, Prime
Okay.
Minister 10-point agenda, NDMA,
Okay.
National Disaster
Indian.
Management Authority.
Okay. Okay. Okay, sir.
National Disaster Management Authority. Uh,
Yeah, I got it,
just,
sir.
yeah, just Google Prime Minister's 10-point agenda on disaster risk reduction.
10-point agenda on DRR.
Yeah, disaster risk
Risk
reduction.
reduction. Okay, got it. Got it, sir.
Yeah, in that there are 10 points are there. That is mainstream DRR in development. Okay.
Yes, risk
You
coverage
you,
for
you
all.
told now all
Right, right.
development sectors, housing,
Yes, yes.
infrastructure, how to bail. Nowadays, we are making in flood prone areas. You are making a uplifted platform. No,
Yes, 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 yes.
that how to get that in
Got it, sir.
landslide risk areas, how to create an infrastructure that reduce the impact of landslides. You cannot
Hmm.
prevent that landslide there, but you can reduce. So that kind of infrastructure must integrate disaster risk management. Then risk coverage, expand the risk insurance. Okay, then women leadership, invest in risk mapping, leverage technology, university network, social media technology, local capacity.
Yes, yes. I
Those
got
are
it, sir.
yeah.
Hmm.
Please, yeah, you can
I
share.
will share it with everybody. So, thank you, sir. Thank you once again,
Yes.
and have a nice day, sir.
Thank you, sir. Thank you all. Because of my kind of working day,
Yes,
it
yes.
was late, and I hope all the slides were visible. And to some extent, I tried to cover most of the areas or the applications.
Yes, sir.
Okay, it's a big area. Okay, thank you, sir.
Yeah.
Thank you.
Thank
Okay.
you. Thank you. Thank you, sir.
Can I leave now, Aman?
Yes, sir. Yes, sir. Yes, sir.
Thank you, sir. Thank you, sir.
Yeah,
Okay.
sure. Next session, Sri Lakshmi madam, are you available? So we can,
Yes, sir.
yeah.
That I will call for the next session.
Okay. Let's quickly start the next session. Thank you, sir. Okay.
I hope Manu Madhavan sir is online. Can we start, sir?
Yes, I hope I'm audible, right?
Yes, sir. You're audible. Okay, so now we are moving on to the session 12 of day 6 of Atal online FTP. The topic of the session is Deep Belief Network Based Representation Learning for Medical Applications. The session will be handled by Dr. Manu Madhavan, who is an assistant professor in Department of Computer Science and Engineering at IIITK, Kottayam, Kerala. He holds a PhD in Computer Science and Engineering from NIT Calicut, with research focused on computational analysis of ink RNA, functional signatures, and disease association. Dr. Manu Madhavan has published extensively in reputed journals and conferences. He's also actively involved in fund research projects spanning AI, language technologies, and cultural heritage applications. I invite you, sir, for the session of Atal FTP. Now the stage is all yours, sir.
Thank you. I hope I'm audible. Let me share.
Um, a bit more loud will be better.
Yeah. What about now?
Yeah, now it is okay.
And hope that my screen is also visible.
Yes, sir.
Now it's in presentation mode. Yeah. Shall I start?
Yes, sir, you can.
Yeah. Thank you. So very good evening, one and all, and thank you for this opportunity to talk about this particular topic in this Adal FDP after a very different topic on forestry and landscape geographical details. I'm going to some other extent which is about biomedical applications. So the plan for today is introduce deep belief network, and we'll discuss the background of what is deep belief network, how it is connected to the deep learning concepts, and why the the concept, the architecture is still important even in the current trend of generative AIs, transformers and L. So it is very like a very unrated model, I will say, very powerful at the same time because of the other models. Maybe because of the current GPU availability, resource availability, and all, this model may not be that much popular compared to the other deep learning models. But still, we'll see why this model, why this kind of architecture were proposed, how it is different from a traditional deep learning models of any kind. That details will be discussed as part of this, and we'll come into biomedical application. Even though it is biomedical, you can I will focus on to bioinformatics applications, but you can extend to any other applications too. So we'll give some guidelines to where you can explore other applications of DBN from literature. That's the plan for today. I will start with deep belief network. What is deep belief network? Before starting, what is DBN? We'll talk about probabilistic models. So DBN is basically a probabilistic model. So we should know what is meant by probabilistic machine learning or probabilistic learning in general. How deep learning plays an important role in probabilistic models. Then there are multiple probabilistic models available. So this is particularly a Boltzmann machine. So we'll understand what is the peculiarity of Boltzmann machine. And in specifically, this is a restricted Boltzmann machine. So we'll talk about what is restricted Boltzmann machine. And they are learning the training algorithm they are using is convergence divergence. So constructive divergence. So CD algorithm, what it is, will be discussed. And finally, how all this simple components can be uh, coped together, like connected together to form the final DBN architecture. Once the DBN is ready, how we can train the DBN models, how to update the parameters. So training in the sense how to get the model parameters ready. Once the model parameter is ready, we'll do a fine tuning. We can do like where we can apply the DBN for, or what kind of application can be solved by DBN. And we'll take a small implementation demo as well as some use cases or case studies where the DBN architecture is used for learning the features from the model. So that is what the plan for today, detailed or very one line thing. So the question is why this topic, why deep belief network in this FDP? Especially when deep learning models and the higher order models like transformer LLMs and all very popular. Why this is important? One is the talk is about DBN on biomedical data. Biomedical data means, for your clarity, or those who are very new to biomedical data, it may be molecular data or genetic data or some kind of imaging like X-ray images or EMR, like brain images, MRI images, what kind of images is possible from the like, or it can be histogram, it can be ECG signals, it can be electronic health record, even like doctor's prescriptions, lab results. It can be anything that related to the health and things. And what biomedical data analysis includes is analyze this kind of data for better diagnosis or better designing the treatment plan or better identifying the anomalies, especially using computational tools. So many image processing related applications you may see in medical images, like identify the cancer from a particular image signals, or identify some anomalies in the X-ray, or identifying anomalies in the ECG signal. So all this will related to biomedical. Bioinformatics is also a part of biomedical data analysis. We are focusing on the genetic data instead of the other physiological reports. We are taking the genome sequences, how genes interact with other molecules like proteins or drugs, component, all that kind of interactions will be considered as the data here, and we'll work on that. Now, when come to this biomedical data analysis, you can see that this data will be very high dimensional. Like if you take our system, it contains the interaction of thousands of molecules, like not thousand, you cannot, enormous of molecular interactions happening inside the body. So if we represent that as a graph, an interaction graph, the complexity of that graph will be very high. So in biomedical literature, like any other complex domain, we are dealing with high dimensional data. In most cases, this will be noisy. That indicate the data, how we collected may be noisy. That doesn't indicate that biomedical data is completely noisy. That it include many other problems when we are collecting the information, and somehow it may be sparse also. We may not get the exact details of each and every component in the biomedical system. So there may be a sparse data. So if we work with classical ML models and deep learning models, ML in the sense it covers all the traditional and deep learning models, it may struggle with how to get the features, exact features from the, or extract the features from the raw data will be very difficult. And most of these ML models will be supervised in nature, are trained for linear models. They struggle with representation learning, how to represent the data so that this model can be better perform on the decisions. And in many cases, there will be certain uncertainties. So we need to model them using probability. But the traditional deep learning models are not probabilistic, they are deterministic in nature. They're trained on a supervised data, they are deterministic in nature. So the problem here, what we are going to discuss is when the data is uncertain, which need a probabilistic model, at the same time, for learning this unstructured complex features, we need deep learning. So how we can combine the concept of probabilistic learning plus deep learning concepts, or probabilistic deep learning, deep neural networks. Can we have such a model where the deep neurons will work on the probability? They may produce a probability distribution to address these uncertainties. I'm not talking about generating the probability at the output layer using a softmax. Using some distributional property, it understand the distribution of the data. Say they follow a Boltzmann distribution, they follow a Poisson distribution. So based on the distribution, it can generate some data, estimate what could be the model parameters. Instead of end-to-end training, can we estimate the model parameters using the probability distribution within the neural network? That is the core idea of this probabilistic model, especially the DBN, what we are going to discuss today. So before moving, we are talking about learning. So this learning in the sense how we are modeling the data. So learning is basically how we are learning the parameters. So a model is basically a set of parameters. I'm not talking about the hyperparameter, the model parameters, how we are learning the parameter from the data. And this can be there can be two types of learning. One is a discriminative learning or a generative learning. A discriminative model means it tries to make a decision boundary, say a classification. Like given X-ray image, we want to check whether it contain a particular anomaly or not. A binary classification we can see. On the other hand, generative models, based on the data distribution, it will create new such data. For example, GAN, generative models, generative adversarial network, or the current GPT models. They are generative models. They generate the new data based on the full data distribution they learned from the other, like the training corpus. And what we are going to discuss today is DBN, which belongs to the generative model. So it's a generative model. That doesn't indicate like it is used for generating new data. It can be used for generation, but this generation will be based on some probability distribution. It's assume a Gibbs sampling. So this distribution, this generation ability can be used to extract the features from the raw data. In an unsupervised way, we can learn the data representation from a complex connected data. That is the advantage of DBN. And why we need a probabilistic modeling? Because this models in many cases working with a unseen data or uncertainty. So we need to quantify this uncertainty. So it directly linked to the probability. And there may be some missing data because we already mentioned that what the domain we are going to use will be working with many uncertain, sparse, noisy data. So when there are some uncertainty, the right mathematical modeling will be based on the probability. And there are many very non-performing probabilistic model we already know, like a maximum likelihood modeling, or naive Bayes, very simple, or HMMs for many applications, Bayesian network and Gaussian process, like lot of application you can see where this particular probabilistic concept is used for modeling the data, learning the parameters. So the question is, from probability, how we can connect it to neural network? Or the question is, can neural network represent probability distribution? Or can we train a neural network to represent or learn the probability distribution? So the question is, or the idea is, instead of predicting a single deterministic value as in normal neural network, can we specialize, can we train the architectures to output some parameters like the mean and variance of the data for a probability distribution? So I assume that this data, or I learn that this data follows certain distribution. From this, can I learn the probability? So the neurons, instead of predicting the model weights, can they map to a particular probability value? That is what GANs and mixed density model, many other models are doing. So in or in more formally, we can say that in probabilistic model, what we have is we are learning a probability of X. Maybe in a binary classification, we say what is the probability that this X will compute the probability of certain events and say that for this, the sum of this probability should be 1. So instead of directly modeling this probability, we want our neural network model do something simpler. We'll move this value to something different. So the idea is we want to learn a energy function, sorry for the typo, over an input operations. Let me move it to the top. So instead of this, we map the probability, like probability that a particular output is given based on the X, input X, which is a energy function. The function can be defined according to the model. Let's say this is an exponential function, which is normalized by a factor, normal factor z of x. So what is z of x? What is e of x? That is not a matter. We just want to map this probability of input-output pairs, like how x map to y. Y is the output, x is this. That is basically an expectation, exponential of the expectation of x and y, which is normalized by a set score of x, some factor of x. We want to compute it. So the key idea in energy-based model is that we have to train the model that assign low energy to the observed correct data points. So we know that a model is stable when it is in a low energy state. This is coming from thermodynamics or physics. So we want to learn the weights in such a way that the model energy should be minimum if we want to move to the low energy state. So if the model assigns a low energy weights that indicate that the data points have a high energy to, like they have a configuration. Suppose the model generated value is low energy, that indicates that is correct, then high energy, which leads to an incorrect prediction or incorrect modeling. So it is parameterized using the neural network. So this can be learned. A neural network will learn to understand this energy function instead of directly learning the probability. They want to find a energy function in such a way that, so this will allow the highly complex and nonlinear relation between the variables. So if it want to predict a low energy for the correct prediction or correct modeling, and high energy for a incorrect prediction. So it will this energy function will be learned. We don't know what is the exact energy function is, or we don't know what is the exact probability. So it will learn this probability by turning this exponential function, this particular function, into a probabilistic value. That is basically an energy-based model. So the next question is, we have an energy-based model which can map the input-output pair to a probabilistic notion based on the energy function. What kind of neural network can naturally define such energy function? So how we can define a particular neural network structure? So neural network means we have a network of neurons. We know what is a neuron, a perceptron. We are not going to the perceptron learning details, but if we have a perceptron, a mixture of perceptron, what kind of neural network can naturally define such an energy function? So the solution that proposed for this question is Boltzmann machine, a neural network with an energy function. So a Boltzmann machine is a neural network where the weights and biases directly defined by an energy function over the network state. So Wij and Xi are the parameters what we have. So this model will compute. So the energy function will be defined in terms of the weights and the bias parameter of the model. And each neuron node in the Boltzmann machine will be a kind of binary random variable which can predict either 0 or 1. So it can be either 0 or 1. And the connection will be the pairwise interaction. So all neurons will be connected together. Their interaction defined like whether it will be interacting or not. And this interaction have a parameter weight Wij between I and j. And biases define the preference of activation, like in or what order they will be activated. So this function will be given to a neural network. So neural network wants to identify the parameter weights Wij and Bi using the backpropagation so that the energy will be minimum. We want to minimize this energy. So the energy of X is the data set that is defined, the samples, which is defined in terms of this Wij, W and B, we can say general bias and weight parameter. So this is what structure of Boltzmann network. You can see that there are two types of nodes. One is visible nodes, where the interaction is visible. We know what happened to the model. Like we know what is like what is happening with the data point or the neuron. And we also have some other neurons, hidden neurons, where the output or the property is not explicitly mentioned. So we have two kinds of nodes here, a hidden layer, hidden neurons, and a visible nodes. Whatever be the type of the node, all are connected, interconnected with certain bias and weight parameters. So all the connections have the corresponding bias and the variance value. And we follow a Boltzmann distribution here, which assigns higher probability to lower energy states. So higher the probability means lower the states, or lower the energy means higher the probability, making the system more stable at minimum energy. So the model learns the weights to minimize the energy. So energy function is already defined here. The model is trained, this kind of network is trained in such a way that the total energy, the energy of the model should be minimum. But the problem here is very simple neural network. It can be like it's collection of neurons. You cannot correlate with the traditional neural network where we have one layer of input, the other like that. This is generative model. Like the nodes which we mentioned as visible are, we know the distribution, we know the things, and here we just observe, but we don't know the details. The properties of this hidden nodes cannot be visible. It is not explicit. So based on this, we want to adjust the parameter of the other models also. That is the key part in Boltzmann machine. So Boltzmann machine is a very simple neural network whose weights defined and whose probability distribution is derived from the energy. But the problem in a full Boltzmann machine that we shown in this figure, there will be a complex connection, and every node is connected to each and other, so the connection grow exponentially. Like as the number of nodes increases, you can see there will be, for each node there will be n minus, like for n nodes there will be n minus 1 connection, so n into n minus 1 connections will be there. And as one increases, like n minus 1 connections will be increased. Like for one node we have to connect with the remaining n nodes, so that much connections will be there. So the connection increases exponentially, grow exponentially as the size of the network increases, size of the neurons increases, which is computationally heavy, which sometimes we cannot compute it properly. Anything exponential means it's a kind of non-polynomial deterministic problem. So we may not complete the problem in time on time. So it is not practically advisable to work with the problem which is exponentially growing. So that will be difficult for computation. So each node in the visible layer. So what we are putting is we are modifying this architecture to a restricted model. So the new addition is called restricted Boltzmann machine, RBM. So the second part is correct. Like only we are adding an adjective called restricted. So what is the restriction we are imposing here? We say that the nodes, we have two layers now. One is visible layer, the other one is hidden layer. So the neurons within the visible layers are not connected. Neurons within the hidden layers are not connected. The connection is just between the hidden layer and the visible layer. All neurons in the hidden layer is connected to other neurons in the visible layer. The connection is bidirectional, undirected, but there is no connection between the nodes in the same layer, within the layer. So that is the restriction we are adding. That will reduce the number of connections, and especially we will get a bidirectional, like it's a bipartition. This is kind of bipartition graph. We got a bipartition compound from the network, and this network will be trained to learn the parameter weight. So visible nodes connected to one another. This is wrong. Like this indicate that this is connected to the other thing in the, there is no connection between the visible layer 2. Now we can take this as an energy function between the hidden layer and the visible layer, where E is the energy function, V is the visible layer's state vector, means all the values, all the vectors in the visible layer. H is the corresponding in the hidden layer, and A and B are the biases in the both hidden and visible state, and W is the weight matrix across the between the hidden and weight. So we got a hidden energy function, and we want to minimize this energy function. So we want to train the model to minimize this energy. So how we can do that? We'll introduce a concept called constructive divergence. Sorry, contrastive divergence. So this is a kind of generative model. So from the visible unit, it apply a Gibbs sampling to estimate the gradient needed for the weight update. So it is not a end-to-end training. Instead, with the sampling, with the sample of the parameter it generated, it computed, it apply a sampling, a probabilistic distribution to get the updates of the other things. So if you look into the step-by-step implementation of a RBM, restricted Boltzmann machine, initially the parameters will be randomly assigned some values. Then based on that, it compute the probabilities of hidden units, then sample the hidden configuration, reconstruct the visible unit, and update the parameters. So the main difference between a traditional deep learning model and training a traditional deep learning model using backpropagation and training a RBM is that here we are applying a probability distribution. In this case, we are applying a Gibbs sampling to get the values, probability construction, and reconstruct the visible unit. So if then we reconstructed the visible unit and checked the divergence. How correct the visible unit generated by from the hidden configuration. So we actually have some visible unit. Based on that, by applying some probabilities of the hidden units were computed, and based on the probability, by applying the Gibbs distribution, we reconstructed the visible unit, that is constructive divergence. And the difference between the constructed and the actual visible units we computed. Accordingly, the model parameters get updated. Backpropagation. This will be repeated for some number of steps until we are getting a convergence, or some fixed number of steps, like maximum epochs we can say. We'll repeat it until we are reaching a converging point. So this method makes the computation very easy, because we are not training the model end to end. And compared to the Boltzmann machine, we put some restrictions. So the computation also reduced. So compared to the other probabilistic model till date, the RBM was very powerful, computational friendly, because then the required resources for this training was very less. So this one RBM approach was very powerful and solved many of the complex problems in the domain. So people think about if one RBM is so much powerful, why can't we stack them? Why can't have multiple layers of RBM? So it become more powerful. Exactly that leads to the idea of DBN, where we are stacking the RBN, stacking the restricted Boltzmann machine, and finally we'll get a stacked architecture, a layered architecture of RBM, which is called deep belief network. So deep in this DBN is basically the stacking of RBMs to get the better learning. And thus stacking will leads to idea of hierarchical representation learning. So the feature what we are learning as conducted, like the initial layers will learn general features. Then when we are moving to the hidden more hidden RBM layers, it will capture some of the specific features. So that kind of hierarchy is maintained when the features are learned from the DPN model. So this is a particular architecture. This is what the DBN architecture means. We have an input layer followed by multiple hidden layers. So this input layer and this hidden layer follows one RBM, and then the hidden layer 1 and hidden layer 2 follows the next RBM. This then 2 and 3 follow like that. It will be shared. The layers will be shared. So first RBM followed to the next RBM, like that. Here we can see 1, 2, 3 RBMs, and finally we have the output layer. And similar to the RBM, we have a similar energy function is there, and each layer will be trained separately. So this is layer wise optimization. We are not like in compared to the other traditional neural network model. If you remember how the backpropagation is working, it will first go from input layer to the output layer through different hidden layers. For compute like the forward pass, compute the compute the error, backpropagate the error, compute the gradient with respect to the like error with respect to the parameters, update the parameters. So that is the usual flow from start to end, complete training, end-to-end training. But here we are doing the training layer-wise. The probability of a given state of the RBM is defined by Boltzmann distribution instead of the Gibbs sampling. And the training algorithm, what we just discussed, is contrastive divergence. So that is why the DBN is called a generative model. It will generate based on the Boltzmann distribution and the computer probabilities. Check the reconstruction error, the contrastive divergence between the actual and the reconstructed visible units. This process will repeat until we are getting the convergence. So this is the training. This is how the DBN architecture is working. And usually we'll say the low layers in the DBN architecture will learn the local pattern, and when we are going to the higher layers, it will get a more abstract features. For example, we can say in an image, the lower layers will capture the DBN lower layers will capture the pixel level properties. When it moves to the top layers or higher layers, it will get what a collection of pictures means. Like this is this particular part is this particular pixels group to form a chair. The other one is something else, like some other features of the image. Or in a text basis, we can say initially we say talk about the character distribution. Maybe in the higher levels, we'll get what this word means and how it is connected to the other way. So the features will learn in layer wise, and this layer wise learning will give a hierarchy of the features, hierarchy of the representation. So this idea, this layer-wise learning and this hierarchical features solve the issues of vanishing gradient, which was one of the most subtle problem in the uh, deep learning models, especially RNNs and LST, not LSTM, RNNs especially. So this kind of problems in the training a complex neural network can be handled when we are taking this kind of DBN architecture. And we already discussed many differences between DBN and deep neural network. At any point, if you have any queries, please let me know. Because I'm just talking about the architecture. So if it is not clear at any point, please let me know.
Being one desk from Amazon. Sir, actually, it's a core architecture level discussion and sir, actually, this um, in RBM, so I think there is no this kind of visible hidden connections in RBM.
Yeah, no.
So why there are no that part? Why there is no that hidden connections in the RBM?
No, the idea of RBM is like if you consider this Boltzmann machine, we are not separating this connector. We are taking all the connections. It's a fully connected network. So the number of connections are very high, like exponential. So training such a network will be very tiresome. So instead of that, here restricted Boltzmann RBM follows a different approach. Like it separate out visible and hidden layers separately. And from based on the visible layers, it will calculate the probability of the hidden units, because that probability we don't know. It compute the probability, estimate the probability.
Sir, then what will be the, I think this auto encoders and all,
Yeah,
they are also
they are also doing the same, but
same.
auto encoders are not probabilistic.
Okay.
That's the
They
difference.
are
Here
deterministic.
they have the things like once they estimated the probability. Based on the probability, they reconstruct the visible unit.
Okay.
That's for that they are assuming some probability distribution like Gibbs sampling or a Boltzmann sampling, Poisson distribution, whatever the distribution that's fine suitable. They originally they are using I think Gibbs sampling, and then compute the divergence. The philosophy is same, like autoencoder is also doing a similar thing. But that is deterministic in nature. Here it is probabilistic in nature and generative in nature.
So, compared to then autoencoders, that their learning part, that their main objective of their learning is that data likelihood itself, or what that minimizing the error.
For like they define in terms here the error or the loss is defined in terms of energy. We want a minimum energy. There we'll talk in terms of but the energy is related to probability. But there we are talking about energy, or instead of energy, we call it as error. The error between the input and the output. The difference between the input and output. The main difference is generative and probabilistic. The other one is deterministic and non-probabilistic.
Okay. So in RPM, basically, the training method will be like a sampling based
Yeah,
method.
training that is called constructive divergence.
Okay.
Contrastive divergence based on the sample, the probability will construct the visible unit and then compute the divergence. How differ it from the actual? The predicted one is different from the actual.
Oh,
Accordingly, we
then.
will change the parameters. It's very
Okay.
similar to the backpropagation.
But in autoencoders and all, I think they are using the backpropagation only.
Yeah, directly.
Okay. Okay. Um,
Like these are
then
like
it
before
will be
the
a little
autoencoder.
harder, I think, for the stability and all. The training will be, I think, a little bit um,
Like
much harder.
autoencoders, basically this autoencoders coming after the RBM models. Like RBM, they use the many concepts from RBM. They are like introduced initially. So on a specific set of data, like a small data set on a private data set, this kind of RBM models will be very easy. But when it comes to autoencoders, they are popular because they are working on a GPU, like they can work with the plenty of resources. So that is one difference where the RBMs and autoencoders and its variants stands. We cannot say RBM is better than autoencoders in many cases, or if you see the literature, autoencoders become more popular than
Yes, yes.
RBM and other things.
Mm.
Even DBN also, like you can see many, it's less popular compared to the other deep learning models.
Yes, yes, yes.
Uh,
Especially for generative modeling,
yes, GAN and
GAN and all,
later transformer become more popular because they are
variable
fully
autoencoders
deterministic
and all.
model.
Yes.
But
Okay, sir.
these models are important when
Mm.
there are some uncertainty, especially the data is noisy, some missing things are there. We need to work with some uncertain, like probability. Then, especially on this like medical domain or image imputing, that kind of areas, this probabilistic models will be more suitable, especially when we are working with a small environment with less access to the resources. This
Yes.
model will be better.
So
So
what about
yes,
for the time series modeling and all? Can we use RPM?
yeah, there are works which use time series data also. We could like maybe some kind of adaptation may be required. I'm not sure, but there are works which use DBN for time series modeling.
Okay, sir.
Okay.
Thank you. I think we can continue the session.
Yeah. Thank you.
Thank you, sir.
So that is how the RBM turns to a deep belief network. So we have a stacked RBM connections, and the philosophy is saying we use construct contrastive divergence algorithm for learning the parameters. And the difference between a traditional is this is layer wise learning, like each layer will be optimized and we'll go to the next layer. But here it is an end-to-end training happening in a deep neural network architecture. And one is generative, the other one is deterministic. And we are not using the probabilistic model in a DNN concept. Probabilistic means, please understand, we are using a generative based on the probability. Only we are estimating the parameters. Uh, Probability in assigning probability to a class label in the output layer is different. So we are talking about how the probability is used to estimate the parameters. And training usually happen in two level. One is because we are working with unsupervised data. So first we want to do a pre-training, train the RBM layers by layer. And finally, we'll do a classifier and do a backpropagation to fine tune for the domain task. So the first layer, like unsupervised pre-training, will help the model to learn the features, the hierarchical features, and then a classifier will be trained to make the prediction based on the learned feature representation, the hierarchical feature representation from the RBM layers. This is how so the same concept we are now applying in transform models, a pre-training followed by a fine tuning, but it was there with respect to the things also. I'm just demonstrating how you can implement a small DBN. That is not much important. We will go to the application directly, but we'll just show you. If you are interested, you can try to implement it from using simple Python program, and you can see how like how easy to implement it compared to the current models. So simplicity is the main thing here. Like, it is conceptually simple. If you understand the probabilistic model in general, then easily you can know what is the power of DBN, or how simple the DBN concept is. So we are using very traditional scikit-learn packages, NumPy for dataset and pandas. The problem what we are doing here is we are taking an imaged dataset, and we want to predict the image. It's basically an image classification. We have the image and the corresponding target values are here. So, and the traditional machine learning steps we followed here, we load the data set, split the data into test and train, and the corresponding Y train and Y test, and do some normalization, standardization, and finally we got the trained and test data and a normalized standardized data set. Here is how we are implementing the DBN part. We call the RBM layer, which follows a linear RBM function, which is already there, with 250 neurons in the things, and the learning rate is 0.01, and number of iteration is 20. We defined all the things. Here we just put one layer. We can include multiple RBM layers as you wish, and we just created a logistic regression. Final classification will be based on the logistic regression. So this is for training. So first we train the model. So for this training, we have first RBM followed by a logistic regression. So first we'll train the RBM model. So this is the pre-training of the DBN model. So we can have multiple RBMs, but currently we had one layer. So we can have multiple RBM layers here that will be trained. Then the logistic regression, which is the classifier, will be trained to predict the class label. And dot fit function will train the model, and we will get the final score on the test and data. And the result is like somewhat 0.76, 0.78 class accuracy you can get because we haven't done much optimization here. You can include all other hyperparameters, the number of neurons and all, to get the improved result. But what I mean is implementing a DBN is as simple as like this. So that is about the coding part, but we'll talk about application in like general as well as biomedical domain in the next part. So the first half of the session is done, or major part of the session is done, which introduced the concept of deep belief network, not in depth, but in with mostly with intuition. So we started with the probabilistic learning and how the energy function is connected with the probabilistic learning. Then from this probabilistic learning, we have generative models. From generative models, we have Boltzmann machine. From Boltzmann machine, we move to restricted Boltzmann machine, and stacking the RBM, we got the DBN. This is how the concepts till this point are connected, uh, connected logically. Now, where we can or how we can use DBN, or why we have to use DBN. So one application that with DBN can be used is called representation learning. So what is meant by representation learning? We already discussed that the different layers of the DBN will learn the hierarchical relation between the features. So it can be used to learn complex features from like unsupervised feature learning can be applied on a complex data. For example, biomedical data itself. There will be a lot of complex interaction between the molecule. We are giving the graph, the interaction graph. Can we learn a representation? Can we learn an embedding from the data? Or we are giving an image and like a collection of images. We want to get the features. Or text we are giving. From the text, we want to learn the features. So unsupervised feature learning, which learns the hierarchical relation between the features. So hierarchical feature learning, unsupervised feature learning. So this is the key advantage of using a DBN for representational learning. We'll talk about one use case which use DBN for representational learning on a bioinformatics application. Second one is dimensionality reduction, because it learns the concept from a specific to more general, or a general key points to more abstract concept. We can use it for dimensionality reduction. So if we want to place the data in a low dimensional latent space, so latent space means the hidden representation learned by the model. We can define the number of based on the number of hidden units that we are defining, we'll get a low dimensional space or a high dimensional space or whatever we want. And especially the hierarchy, if we follow the hierarchy, that we, by taking the more abstract concept, we can do a dimensionality reduction using DBN. And of course, we can use it for classification and prediction. We already discussed about fine tuning the model. Using the supervised fine tuning, we can combine the pre-trained representation learning model plus a classifier, either a neural network or any other traditional machine learning neural network. We can do it as a predictor or a classifier. And most importantly, these are generative models, so we can use it for generative modeling, like model joint probability distribution of the data, generate new realistic samples can be generated. There are a lot of applications where DBN is used to generate synthetic images in image processing computer vision applications. Now, in under these categories, if you specifically look into biomedical applications, you can see that the representation learning will be very crucial in modeling the complex biological networks or graphs. For example, a molecular graph in citing the interaction between genes and different molecules in the cell, or a disease patient network. That kind of complex network can be represented, a disease symptom and patient network. That kind of complex network, we can use DBN for representation learning. Or a microarray data, if you want to visualize in a low dimensional space, we can use DBN. We already talked about classification. You want to classify an image as diseased or not, or you want to predict where the drug will interact, what will be the target protein of this particular drug. So whether this drug and this protein will interact, or this molecule and this gene and this disease have an interaction, you want to predict. So that prediction can be modeled using a DBN classifier. And if you want to do some kind of missing data imputation or synthetic biomedical data generation, this the generative capability of DBN can be explored. Let's take one particular application. This is one of our paper. I did part of my PhD. We proposed a approach called DBN LDA, where deep belief network was used to learn the representation from a complex network formed from LNC RNA and disease. So this architecture is basically using the representation learning capability, or how the hierarchical features can be learned from a complex data. Is there any chat in the list? No, it's not for me. Sorry. So the idea is we first model the complex interaction between different molecules as a graph. In this particular case, I will go to the architecture diagram. We are taking three different graphs, different nodes. One is LNC RNA. For your understanding, LNC RNAs are a particular type of RNA. You may heard about gene or DNA RNA protein. So it's a particular kind of RNAs. We call it as non-coding RNA. Generally, the gene, from a very peripheral overview I'm giving, DNA is transcribed into RNA, and this RNA will be converted, like translated into the protein. That is a normal flow of information. But not all the RNA will be converted into protein. There are some RNA which, like a gene, which is transcribed into RNA, but not translated into protein. So these are called non-coding RNA. Among this non-coding RNA, some of them are called long non-coding RNA because they have length greater than, length means the number of nucleotides, ACTG, that is greater than 200. So these are the non-coding RNA. And there are some other non-coding RNA called microRNA. And we are taking diseases also. So we are taking three different entities. One is long non-coding RNA, microRNA, and diseases. Based on their interactions, we prepared three networks. One is LNC RNA, miRNA interaction. How an LNC RNA and a microRNA are interacting. Similarly, we constructed another network which is for disease and miRNA interaction and LNC RNA and disease interaction. We already know some LNC RNAs are interacted with some diseases. And we already know some diseases are interacting with miRNA. So that connection we form. So usually we can also form it as a complex single graph. Instead of, for a better learning, what we proposed is we divided them into three separate graphs and apply a algorithm called node to vec, which will convert each node into a vector. So what is the input to the core part is vectors of each of the node along with their relations. So from this graph, I'm taking LNCRNA embedding, and from this particular graph, I'm taking disease embedding, and from this LDA part, I will be taking both L and D, like LNCRNA and disease. And this will be given to a DBN, not one DBN. If you see here, from LNCRNA miRNA interaction and disease miRNA interaction, I will get representation for L and D. I will train a DBN network here and learn a representation of LNCRNA and disease from here. Similarly, here I will take the representation of LNCRNA and disease. That will also pass through a DBN to get the representation, hierarchical representation. And in the third layer, both from this subnetwork, both are DBN. I will be combining here. I will pass through. So I will pass through three different DBN. So I will get a different LNCRNA disease interaction, disease embedding, and which will pass through this DBN and we'll get a representation, final representation here. And this final representation will go through some classification. This is basically a classification layer. I will add an attention layer, then a neural network classifier, which will predict a score, which says what is the probability that this L and this LNCRNA and this disease is being associated. And based on the threshold, I can fix if it is above 80%, they are interacting, or above 50%, the score is above 0.5, I can say they are interacting. So this is a core idea, core architecture. The architecture is also simple. And here we used DBN for learning the representation. So what the input to this DBN is graph or vector embedding. So this vector embedding is actually capturing the relationship. So graph is given as an input. From the complex graph, they learn the representation between the models and gave the output. Though the architecture is simple, the concept is simple, we got a good improvement. You can see the overall accuracy of this model. The AUC curve, the area under ROC curve, the model give a good result around 0.963, second among all the results, and very close to this RFLDA, which use a random forest algorithm. And especially here you can see the improvement over the AUPR value, the area under precision recall curve. That indicator is more robust result we are getting compared to the existing models. By using the DBN feature representation, like in all the cases, the concept is same. They are using a classifier, some method for learning the graph representation, like Ping's method or GAM method, CNN method, GCNLD. All these algorithms, they use some methods to capture the representation from a complex network. But here we use DBN. Also, that subgraph concept is also novel from our work. This three different graphs, or this layered architecture of DBN is also a contribution from our side, which leads better performance compared to the state of the art model. This sorry, I hope I am audible, right?
Yes, sir.
Yeah,
Now
sorry,
it's
sorry.
fine.
Yeah. At this point, so this is one work we used DBN in a bioinformatics application. Similar to that, we have one more application I can show you. Is an extension of what we have done. We used the DBN features. Like in the previous application, you can see this is a kind of classification. We classified the DBN features. Based on the DBN features, we trained a classifier to predict whether the LNC, RNA, and disease are associated. But here, what we have done is we use the DBN features, the feature we extracted from the DBN using DBN as for clustering the data. We clustered the result, the graph. For a graph clustering, basically we can say we applied the graph cluster and identify the LNC RNAs which are key in heart failure. So we take a heart failure as a case study. We identify the LNC RNA, miRNA, mRNA. mRNA means the genes from the biological database. We did some kind of biological pre-processing, like some bioinformatics standard pipelines are there to identify the differentially expressing genes in particular disease condition. So from we taking the from these kind of publicly available databases like LNC base or TAR base, MIR TAR base, we constructed the corresponding differentially expressed LNC RNA, differentially expressed miRNA, and differentially expressed mRNAs in heart failure. So basically, how we are finding the differentially expressed means this particular database GEO contain both control and disease persons, like LNC RNA expressions of a diseased person and a normal person. A list of LNC-RNA, a list of LNC-RNA in both conditions, or list of miRNA and mRNA. We'll do the differential expression analysis. Using that, we can identify which are the LNC-RNA have a different expression. Expression means how it act in a particular person, whether it have a different action on a disease or a normal person. So based on that, we'll identify which all are the differentially expressed LNC-RNAs, miRNAs, and mRNA. From that, we construct a co-expression network, like which all are the mRNA, which all are the LNC-RNA, which all are the mRNA are co-expressing in the same disease condition. So that will construct a co-expression network. And we find the identify the graph embedding using some graph algorithms. So we got an embedding of each of the models, which leads to the next level where we apply the DBN, deep belief network, for feature learning. Similar to the previous application, we have a co-expression network. We used deep belief network to identify. Why we use DBN means we already got an exposure in the previous work that DBN will be very useful for learning the features from such a complex network, biological. Like this network may be sparse, at the same time it may be complex also. So we got an idea that this DBN will be better for capturing the features. So we applied this feature learning, and based on the features, we apply a topic model, which is again LDA, latent digital allocation, and again a probabilistic model to get the topic-wise clusters of each of this module. Like we got a cluster where we have both lncRNA, miRNA, and genes will be there. Then we analyze the clusters using uh, some pathway analysis. We identify that some of the lncRNA pathway where this leads to the like some of the heart failure pathway where this lncRNAs are the biomarkers. So that can be used to identify like this part is future work, or this is suggestions to the therapeutic. We are just computer science people. So we are just suggested that this lncRNA or this pathways can be a biomarker or for a heart failure disease. So this is the work. And as far as this session is concerned, the core part is here, how we use the features for clustering. So this can be used for characterized like descriptive analysis of the data also. So DBN basically gives the representation learning, which can be used for multiple applications. So to wrap up what we discussed so far, DBNs unify the probability and deep learning. So we started with the probabilistic model and how it can be connected to deep learning models. That is the solution we propose. Solution as a like DBN is proposed as a solution. And in historically, does DBN make deep learning practical? Like it make the deep learning model more simple, more trainable with or less resource hungry compared to the other models. Because of the other factors, like we have sufficient GPUs now, or we come up with more active, more robust activation functions like ReLU and all. The visibility of DBN was decreased compared like, and other models come into action like generative models like GAN transformers come into more popularity, but DBN still matters in especially when if you want to work with a small data set. Like on a small data set, if you want to implement on a low resource setup, you want to implement a deep learning model, I don't think you can go for a transformer model. You cannot run a transformer model. In that cases, DBN kind of models will be still matter, especially noisy biological data, generative representation and all. And this is one single slide which connect all the concept what we discussed so far. We started with a probabilistic model. It's the problem is how to convert this probability into energy function. This leads to the energy based model EBM. Boltzmann machine is one of the EBM plus neural network, like connecting this energy plus Boltzmann, like the neural network plus this energy function. We have the Boltzmann machine, but it have limitation of complex structure. So apply the restrictions. We got the restricted machines. Then stacking them, we are getting the hierarchical learning model, which is called deep belief network. So that is what we discussed so far. And for further reading, you can go with the basic paper of deep belief network by Hinton and Geoffrey, those who proposed this architecture. And if you search Google IEEE or Google Scholar, you can find lot of like with the keyword DBN and biomedical, or DBN plus your NLP, DBN plus computer vision. You can find the interesting literature where the DBN is used for different application. Especially this is a review on contribution of future, like how DBN is used for electrocephalography, like biomedical engineering application. And DBN for bioinformatics, one paper is there, research paper review paper is there. Many other applications you can see if you just go through the Google Scholar. And some of the improvements over modified DBN architectures you can see in the literature with DBNs, dynamic DBN, recurrent DBN, that kind of DBN concepts are there. So, like as Sir asked about time series models, you can have DBN for time series, like some modified DBN for time series data will be there. That also you can explore. So there's very short introduction to DBN and its application. The one thing that I like, you may think why DBN in this era of LLM, but my solution, my answer is uh, like LLM or AI is not all solution for any problem, like a one solution for all the problem. Based on the problem nature, we have to choose the model. So if your problem us connecting with all the criteria that we discussed now, definitely DBN will be a good choice that is easy to implement and easy to visualize. So this is from my side. I think I'm on time, even though I started little late. Is there any questions? I'm happy to take up or try to answer. Hello. Yeah. So if no other queries, uh, we can wind up and go to the next. Hello. Hello. Am I audible? Okay, fine.
Thank you, sir. Is there anyone else who have any kinds of doubts regarding the session? I hope there is no more doubts regarding the session.
Yeah, fine. Thank you.
So thank you, Dr. Manu Madhavan, sir, for your informative session. Thank you, sir.
For this opportunity. Thank you. Have a nice day. Thank you.
Okay, sir. So shall we move for the next session? I hope Timthya sir is online.
Yes. Is it audible, ma'am?
Yes, sir, it's audible. Okay, so shall we start the session, sir? So today, next we will be having the session 13 of AACT Atal FTP, online FTP. The topic for the session is LLM cases for advanced teaching and research acceleration. The session will be handled by Mr. Imtiaz, MP. He's an accomplished academic and industry professional with over 16 years of experience in teaching and academic administration, along with 4 years of industry exposure, and he currently serves as director at Codespace Technologies, and he has held key leadership roles, including vice principal, IQAC coordinator, head of the department, and has played a pivotal role in securing NAC and NBA accreditations. Mr. Imtiaz has also served on the Board of Studies under APJ Abdul Kalam Technological University and is a sought after resource person for outcome based education and accreditation related initiatives. Welcome you, sir. Welcome you, sir, for the session. Now the session is all yours, sir.
Yeah, thank you. Thank you, ma'am. And thank you that considering me as an resource person for this Adal FTP on LLM. And thanks for inviting me from Royal College of Engineering. So congratulate Royal College of Engineering Technology and also the Department of AI and Data Science for inviting me to participate in this Adal FTP as a resource person also. So I just share my screen. If it is visible means is it visible, ma'am?
Yes, sir. It is visible.
Okay, so that here some bandwidth issues are there. So I just switch off my video for the efficiency of the bandwidth. If it is required means please inform, I'll put on my video. Okay. Okay, mainly that that topic is that large language models. So here, so my topic that is allotted as large language model LLM use cases for advanced teaching and research. So that last 5 days, I think all the major use cases are already discussed, and all the models all the LLMs also discussed, and the main neural networks side and deep learning, everything already discussed. So that my plan is to that go to that LLM as a use cases while we considering as an academician and a researcher, so how to help these AI models that is be effective in our day-to-day academics and day-to-day life as well as our research interest. So that LLM are, that shaping teaching, research and scholarly practices in higher education right now. And something like this, while we talk about the large language models, I think no need of the definitions that I know. Then also that I just say something about these large language models. So actually, that it's an like an intelligent, that is the ultimate goal of our AI, that everybody knows that. And this ML, that is, we are using this machine intelligence method. So method for achieving different type of intelligence. And then we have an LLM tool for the language task. And finally, that our system, that is the generative AI, while we giving a context or giving an instruction to these, and they will be capable of using these LLMs, they will be generative that output. So actually, that is the main concepts that is we are using behind these large language models. And that popular, GPT, Claude, Llama, and Gemini. So already all are discussed. And while we go for this, why that is this LLMs matter for faculty today, that is the widespread of adoption. That is the main reason that is we are most of the nowadays that discussing that AI and AI structures and LLM models. So because of this widespread adoption, that is the case study that is the evidence shows that LLM significantly enhance instructional design capabilities in modern learning environment. That is the main thing. That is the next era that will be go to like more effective in these LLMs. So workflow transformation, that is LLMs accelerate our that is research oriented works, that is literature review, that is helpful these LLMs, data analysis and content generations, fundamental reshaping academic workflow. So everything that lot of supports that we can be taken from the our LLMs. And critical readiness, that is the another thing that is we are be go behind, because faculty preparedness is essential to harness AI responsibly, ethically, and effectively in academic context. So that is also very important. It's in ethically and effectively in academic context. And I just considering that LLM in teaching and curriculum design, so that we are all are academicians. So because it's a faculty development program, and we have different discipline faculty members also be there. So that is why considering that mixing all these, how to helpful the LLMs in our teaching curriculum design. So personalized materials, that is streamline creation of customized lesson plans aligned to learning objectives. So that we have generate different like creation of customized lesson plans and in different contexts. So that I'll explain how to prompt of this one. Okay, an assessment and for at very difficult levels. So if you want to set up different level of assessment for different things, so that in previously we have only one adoption. We have to prepare all this and we have to do all this. But here we can help this. We can create or we can generate this assessment at varying difficulty levels with AI-powered writing assistance. And simulation design. So especially the facilitate sophisticated simulation scenario designs and deliver real-time feedback for for students. So that is also be one of the important thing in academics. So you can that a lot of simulation tools of this AI also be available, and you can also use that for the academic and teaching purpose. So then assignment innovation. So that faculty to create a augmented assignments, and build collaborative prompt repositories for enhanced pedagogical practice. That also we can use to our pedagogical practices. And when you come to that research and the productivity with the LLMs, so automated drafting, that is we streamline creation of research proposals, abstracts, and comprehensive literature summaries with AI-powered writing assistants. And we'll discuss some assistant tools also. We'll discuss along with this today. And data interpretation, that is no support complex data interpretation and coding tasks through intelligent analysis frameworks. So that also be one of the important one, data interpretation. That also we can effectively use AI analysis frameworks. And real world impacts that increase in recent computer science papers, including AI assisted writings. So demonstrating growing that integration, that is the real world impact on things. And in literature review and knowledge synthesis, while we come to that in research in D, that is rapid literature scanning. So that is one of the thing while we as an academician. So LMS can process thousands of research papers in a minute. So identify key themes, methodologies, and gaps in existing literature, and would take researchers weeks to uncover manually. And cross-disciplinary connections, that also be very important. That is in previously that that is interdisciplinary like researchers, it's very difficult. So nowadays all are in your fingertips. So that is cross-disciplinary connections. Like AI models excel at identifying unexpected connection between different research domains, fostering interdisciplinary insight and novel research questions. So that also very helpful for us for the cross-disciplinary connections over there. So automated summarization, that generate comprehensive summaries of complex research articles, extracting key findings, methodologies, and implication for your specific research focus. So these are the main things while we consider academician. So we are nowadays that adopting these LLMs and AI agents. See that another important thing is that while we go for to interact with the LLM or these AI agents, so that one of the things that is our previous speakers already talk about prompt engineering and prompt designing, etc. So I just to go to that some listening examples of these prompts. So like that is in my words, it is the four pillars of a that is be a perfect prompt. So like these instructions, then input, context, and output. So that is the four pillars of a perfect prompt. That instruction that is tells the AI what task to perform. So that always we interact with the AI means you have to say that how the task to perform. So that we call it as an instructions. An input, so that the data or content the model should process or work on. So according to your input, what data, that is how this AI has to be processed or work on. So that is the input. Then another important one is that context. So you have to provide a background constraint or rules, or so that the model understand the situations better. So that like that, if today that if you have to see a person, you say hi, then that person also say hi only. And if you have to say something more, they will maybe explain more. So something like that. So that is the all the LLMs, and that is all the AI agents are be working. See that provides background constraints or rules so the model understand the situation better. Then output means that is define the expected format. So that means you have to give that output in which format you record. Then the structure or style of the response. So that these are the four actual pillars of a perfect prompt. So it's very simple. That instruction that input also we know that, and context also you can say in better way, in better constraints, better rules also you can be adding to the your instructions. It means your input. Then output also, that is which format, define the expected format. Okay. And while we coming to that, we have five type of prompts, prompting ways that is very common to the prompt engineering. So, and first one is that zero shot prompting. So like that, you are asking for a result without providing any examples and like that. So just a quick straightforward task that will be under the zero shot. And I'll just move to that one the example. I just explain this one and we can go to that. Okay. So that the next is that few shot prompting. So that means providing one or more input output examples to teach the model a specific style, format or a tone, then complex formatting sensitive or specific output type. If you're giving that input like that, then it called as a few shot prompting. Then chain of thought. One is COT. Either it's called as a chain of thought prompting or it be called as a COT. Then that is the encouraging the model to explain its reasoning step by step before delivering the final answer. So we are giving sometimes that is for thinking that our model, and then that will be considering the mainly that we are using for the complex logic or planning or decision making context that we require the we are using the COT prompting. And next is fourth one is a role or personal prompting. So that is assigning the AI a specific expert role or perspective to shape its tone and knowledge depth, domain specific professional or tailored content. So we have to assign the AI as a one role. Like you say that act as an like uh, uh, senior academician or act as like a professional UI designer. So something like that, you have to say that things in your inputs. Then structured prompting, like clear instructions, like context, input data, and output format requirements, and complex input and specific structured outputs formats, like if you want to generate like a tables or like a JSON, like in passing that value to some other APIs or something like that, you can use JSONs, etc. So that mainly that 1, 2, 3 you may already used, and 4 and 5 actually that is very we are getting more our analysis according to our context in the fourth and fifth. So I just go to that is we giving an example of zero shot and few shot and COT and role based and like role prompting and structured prompting. Okay, I just move to that. I just consider Gemini for Gemini Pro for that zero shot all these five. Okay, I just move to that. Can you see my screen? We need to stop share. So, sir, I can share two screen at a time, or I want to pause one screen and go back to another. Hello.
This PowerPoint is actually visible.
So I want to stop the PowerPoint and go to that now.
I think so. Then only we will be able to see the other screen.
Yeah. So okay. See any that is anything that you need to set up in background for getting that one. The document I can see advanced that is in iPhone, that is computer audio and screen. So I want to actually that show the screen.
Yes, sir. We can see that Google Gemini, that
Yeah,
screen.
fine. Thank you. See, like, okay. See, I'm copying some prompt from my Word file because I'll typing means it may take too much time. So we can go for the our cases. So okay, so like if you have to say like so I opened two Gemini. One is here. I think you can see, and second one is in our right hand side. So that is simply I can I just giving an example like API. So I'm asking this one to that GPT. It like that giving an answer, but it is more general like that is what is API stands for and something like that. And if you're prompting like so like explain API for the in Python, for example, if you have to say and here I put so you can see the difference. Okay, then what happened here? So here that is giving that more that is specific according to our REST API. And they say that it's like REST in Python and step method and things like that. And making the a reset call in Python, we can do like this. And you have to send this API in a JSON like this. This is the API. If you want to send anything to this one, and here that is somewhat like no, that is one is API, and I'm specifically say that explain API for this Python. Okay, next, suppose I am giving another example like explain API with implementation. So that they're giving to explain REST API. So that explain API in REST API of Python with the sample implementation. So it is giving that sample implementation. Okay, then these be the actual difference of the prompting things. So that one that we are be giving that is explain in this means it is like considered like a zero shot. Okay, and we are giving like giving a like no that sample implementation. So that also we can be considered that is we are commonly thinking and we can commonly straightforward inputting that those things we can be called like a zero shot. And if you're to be giving, suppose I'm giving that zero shot for to in an academician. Suppose we are planning for a like a student training in the case of like AI in education, like something like this. Create a 5-day agenda like for a student training program on like AI tools in education. So what they giving? That please wait and see that So it is very that 5-day that is it's automatically that foundation and they study and they giving morning session. So just we are straight away. This is zero shot. Create a 5-day agenda for student training program on AI tools in education. So morning session like that. The afternoon session, day 2, day 3, day 4, and day 5. and also asking like that, would you like to me to create a detailed rubrics for 5-day capstone projects or something like that? And sometimes they provide some videos also for to linking to these things. Okay, and here they generate thing according to our question. And next, I am considering like create a in this side, I put this one, create a session abstract. Okay, example. So I'm specifically that giving some more inputs like example, that context, example one, then topic, generate AI fundamentals. So the abstract is understanding the difference between a search engine and a large language model, LLM, how to use Gemini, ChatGPT, and Claude. So this I'm giving, this we call it as a few shot. So as per our definition that few shot means like providing one or more input output examples to teach. I think you can see to teach the model a specific style and format or a tone or complex format, sensitive or specific output types. So what happened while we giving this one? So that abstract, so target audience students, high school and higher educations, and the abstract artificial intelligence. And participant will be given these large language models and a heavy emphasis planning and key learning objectives so that they are be given. And they ask that this abstract to be more academic for syllabus, and that is more academic for a syllabus or more trendy for student and recruitment postures. So that they'll be giving that abstract and this example. And next I'm giving like the detailed one, like chain of thought. So for that, I'm giving a plan of 3-hour sessions. That plan a 3-hour workshop on using AI automated grading things step by step. First, identify the key learning objective. Second, second one, outline 30-minute introductory lecture. Third, design a 1-hour hands-on activity. Finally, suggest a 30-minute discussion on topic on ethics. So it will consider accordingly. And they're giving introductory lecture and grading revolution as per our requirements, and hands-on activity, then phase 1, phase B, C, etc., and ethical decisions and discussion points and these things. Okay, and the next one. So this is called. We are be saying that step by step. That is we divided, and we are giving that like no that our third one, encouraging the models to explain its reasoning step by step before delivering the final answer, complex logic, plannings, or decision making. And next, I'll go for the decision making. So, like you are a like I already told you that suppose you are a seasoned professor, okay, or we can say is a senior professor. of Computer Science, who has implemented AI in university curricula, drafted proposal to the university administration justifying the need for a 1-week student training program on AI-powered research tools. Focus on productivity gains and ethical compliance. So I'll be giving this one. So here, that is AI, that is we like act as and like an academician in the senior grade professor of a computer science. Okay, and accordingly, they are be giving this data, literature mapping, cognitive data analysis, visualization, and ethical complaints and human in the loop framework. Okay, if you want to get more in that, I recommended like things are there. And if you want to draft the specific ethical use policy, you can say yes means that will be drafted accordingly. So these be our fourth case, assigning the AI a specific expert role. Okay, and the next one is that structured. So that is in structured, mostly that we are using some codes or as symbols or that less than greater than symbols you can be used for this getting a correct delimiter also we can be used to separate that instruction in the context. So I'm just copying that one without these instructions. So I say to the system, like create a 3-day FDP schedule context, target audience is engineering faculty, and goal AI implementation in curriculum constraints. Each day has 2 90-minute sessions, include 30 minutes tea break, and output format, a markdown table. That is, I want a table with the columns. In the columns, I say day, session, topic, description, and the speaker role. So what happened? So it is very amazing. Let know that day one. So we are saying that every day that is having 2 sessions. No. So day one, that is topic like generative engineering shift, that is in 9 to 10:30. Sorry, 3 sessions like 10:30 to 11, 11 to 12:30. That is the morning sessions. Okay. If you want to break the time, you can specify the time also in your context. Then automatically the system will be do accordingly. Okay. And this is the common nature of the system they consider now in the training time. So that is next is like 9 to 10:30, so that it goes. And in between like 10:30 to 11, that is a tea break. Okay. And it's a tea break with a discussion. And speaker role, senior professor, CSA researcher, instructional design, EdTech expert, engineering lab coordinator, that is lab experiments. And it can use the GitHub Copilot also. So the data science. So like that, they'll be giving a 3-day like a program schedule in front of us. If you are giving a 3-day FTP schedule. If you have to say a 3-day FTP schedule on this one, so sometimes that is not be displayed in the table format. You have to format it in the output. So then that type of prompt we call it as a structured form. So in my opinion, on the academician side, you have to use like a either role based or the structured prompt device. So then you will get more precise and more good and more like no that very effective contents. So that is the one of the concept I want to say in the case of the prompting. So this is in 1 day that is or 1.5 hours and able to study all. But these things are the sparks that is I just inserted in your minds, like this type of searching, like that is this type of instructions or context we can give to that our GPTs. then they will give more precise answers. So as an academician, as a researcher, we require a precise and hallucination free, like not we cannot say that free, like so here also that say Gemini can make mistakes, so double check it. So all the GPTs they mentioned that one, but our precise like no that is in structured prompting that this error or these mistakes may less. So that is in my experience, and you may also be experienced in this. Okay, just to move to that slide. Okay, so that we explained that our prompting, like there are other prompting also will be there in the analysis context, and separate prompting is required. And there are six, like up to 9 prompting strategies are there. And I'm not going to the advanced things. I'm just going to that that in as an academician, that is this type of prompting. And like no that most of our speakers has to be talk about already in the LLMs and LLM leaderboard also be discussed. I actually considered leaderboard, but that also be discussed I think in previous speaker. So I just remove that one. And how this one, how do LLM works, the transformer evolution, that transformer architecture that is behind this LLMs. So that is neural network design that uses attention mechanism to understand context across long sequences. So Manu sir also that the previous speaker, just the previous speaker also talk about this neural network and designs, and the capturing like no that now that is sequence of text and capturing nuanced relationship between these words. And another that is thing is that they'll be using this large languages that is not be considering like your long test. So their process that is called is token processing. Like language is broken into tokens like words or subwords, allowing the model to process and predict the next most likely based on learned patterns. Okay, if you have to say like some like that if you have to be not fulfill all the sentences, then also that LLMs has to be predict the next words because of this token processing mechanism. And they can like know that most likely tokens has to be based on the learner's patterns. And massive scale training that models like GPTs are trained on like no that all the our speakers that say that trillions of tokens from like no books, website, and conversations to master intricate these language patterns and the knowledge. Then what is tokenization? That already that is character level, word level, and subword level. In the character level, that split text into individual characters like cat, that is split CAT, and word level means cat and dog, that is cat. Then also one word and dog is another one. Subword level, that is be byte pair encoding. So that is more that is be used in nowadays. That is in use in LLMs. And byte pair encoding like a split word into meaningful chunks. So that is the prediction of the next pattern likely to match. So chunks that is unhappiness, unhappiness is separately. Okay. So it is having like an every is having like a pros and cons, and here also the pros and cons are there. So that is why always they saying that mistakes may happen. So double check it. Okay. And like that one, I just to show that one of the speaker that is about tokenizer. I just show one tokenizer that is in OpenAI. So highly optimized tokenizer specifically designed for GPT models, offer blazing fast performance for production of the our context cases. See, this be like a tokenizer. See how that can you see my screen? Yes. Okay, I just drop our things like create a 5-day FTP agenda for agent. So see that that it is having a 78 characters and the tokens are 17 tokens and the token IDs. If you have to click on the token IDs, you can see that these 17 tokens. So these are the 1, 2, 3, like 17 tokens they'll be considering. So here, if you have to copy this one to Open API, like tokenizer, and also other tokenizers are also available. I'm always using this OpenAI platform for to check that one. Okay, so that's why I just see here, and this is the text we are be given, and accordingly that things that how this one that create. So if you have to click on this one 5104, that is for the create, and here A and 5 different. So like that, there be if creating a token. So this type of methods that is they inside this tokenizer patterns. Okay, so I just to show that see the tokens, how that token is be like that. I show. So I just say that this one is that is be converted to tokens. So you may have doubt how to create the tokens. So like this the pattern like that is no the tokens. Okay. And next stop. So that is about just I just to show you one token. That's also I go to that slide. So next we are moving to like large language model. That is the large language model use cases. Okay, and here I'm just going like use cases for Google AI research assistants. That is, I think most of them known these things for organizing, summarizing, and your personal documents, notes, and online sources like PDF, Google Docs, videos, and web pages to speed up our research learning and content creations. So so I'm just moved to that. I think my screen is visible to all. See here, this is the while we go to that notebook LM, so that if you have to search in Google notebook LM, and this be the interface, and with interface, and here we can be try notebook LM. You have to click on that one, so that will be supposed to like this type of interface. And here, so I just uploaded 2 documents because sometimes it may be low bandwidth means so I can get it all. That's why I just uploaded the material. That's I just to show you. Okay. And here, if you want to that add the sources to here, you can add the sources by using here. And here, there are different type of uploading mechanism. Either you can be USS, and this one is the fastest mode, and deep search also will be there. And here, the web or drive you can be select. And the upload documents will be there. You can upload a PDF for any documents. So one of the thing is that this will be considered your handwritten PDF also considered. So I just to show you an handwritten PDF also. And if you want a website or if you want a Google, suppose sometimes we have a that video where we seen for one like an academician, we are be searching lot of things in YouTube as for our academic and teaching. So if you want to convert the content into a text or notes, so you just give to link to this notebook LM. If it is not copyrighted, then you just copy to here. So it will be converted to the notes also from the your like your YouTube link or your websites. And by the drive also you can do these things, and copy text also, like that also you can do. See here, I just uploaded. So I just uploaded from the my uploading files. I just uploaded two files actually, like one is like question bank. See, I just to show you that question bank how to see a lot of things in my screen, so you don't worry. And here, first I show you. So that is, this one is one of the notes I scanned it. So here, so I'm giving that it's 2019 scheme KTU1 notes I just a requirement design analysis. So these things are for the analysis things, and this be the my module one like PDF notes. So that name is DS module one PDF. Okay, so that I'm giving this same thing to our notebook LM. See here, you can see DS module one. And next is the question bank of the corresponding subject I am uploading. So these two are I uploaded here already. So, and when I uploaded here, so it will be generating like some like content. So that this one is taken from true. Then here you can see that here they are considering these two sources. So that is be here. And if you want to not record this question bank, so you can be uncheck this one, and now this only one source. See, if it is one source, so here one thing is that here one option is that mind map. See, if you are giving the mind map, the system will be generating a like a capsule of mind mapping. And if you have to click on this one, so the data structures module one, that is I just consider only one PDF, that is the handwritten PDF. Okay, and it is the first one is a software life cycle. So in the life cycle, so the requirement analysis, design analysis, no, analysis, and also that see here in algorithm fundamentals, if you have to click on this one, so the characteristics, and here the characteristics again divided, so like input output like things, and analysis of performance like space and time complexity. And if you have to click on time complexity analysis, and this one will be coming here, and this one will be, so it is just like no, that is uh, just a content mapping that is be happen from this. So with this mind map methods, and another one like see here, suppose if you want to create a video of these nodes, so actually that accordingly that creating the things, so if you have to click on this one, so that will be explain these nodes in our left hand side. You can see these nodes, and accordingly that they'll be creating these contents. And if you want to create an audio of this, so sometimes that most of them are reading these things, maybe like very time consuming and things. If you want to store in a audio format, you just click on this one, that will be generate the audio. So it may be take some times. So if you have to create means, that will be creating the video. and if it is video overview is there. And if you want to create a quizzes according to this our materials, you can click on this one, and the quiz patterns that is quizzes will be generating. And if you want to generate tables, so only thing is that if you have to generate these things in the notes, so here you have to say that create so that is generating that contents according to these, and the notation also they considered. And if you, so only thing is that if you want to save this one, you have to be click on the save notes, so that notes will be comes over here. Otherwise, if you are to giving another search over here, it automatically that overwrite one by one. Okay. See that my network is low, so that is why. So otherwise you will get that QC, so that you can be practice in your ways. So this be the one of the things that is every academicians can use this one. And also they are be giving the citations in which page they are be taking in things. So like an research that is if you have to upload a content and giving a literature review on this paper, that means it will be giving a human being that is be design literature, so that it will be considering AI also. So that means I can say, I mean, we can definitely say that it is more beyond our normal literature review. Okay, and that that all the pages, all the citations are comes along with each and every things they consider. So it is amazing that is tool in that is as an academician we can say it's notebook LM that you can use in different scenarios, and you just practice. And this audio, once that audio is generated, you can see like a podcast also you can be design or here. And in the meantime we can like question and answer session also we can be along this over. Okay. And I just move into our next thing because it is nearly 6 o'clock. So, madam, time up to 6:30 now.
Yes,
Madam?
sir.
Okay, fine. And next, I'll go to that Gamma app. So that also one of the that most of the cases our academicians said we need to be create a lot of PPTs for to for the presentations or for our day-to-day academic teaching, etc. So that a very good tool that we can say that is Gamma. If you have to search in Gamma, so I just starting from here because I want to wind up in 6:30, so that for the presentations, so if you want to create a presentation in this any scenario, so that you can give this that our prompt over here. So create a PPT presentation for a network teaching for B.Tech computer science students, computer science students. We can wait for some times. And in this, we'll be creating 10 slides. Actually, it's a fully demo. And you have a minimum credit they'll be giving. And here, no, that first slide, that is neural network foundation and application for B.Tech. Okay. And what is a neural network? So if you want to add anything, so it is not be, uh, you need to add something more inside that you can add to over here like this. You can add and anatomy of neural networks. If you want to delete or anything track to our this one slide up and down, you can do. And real world applications, challenges, hands-on learning, cutting edge summaries. Okay. See, if you are to be satisfied this, you can say like generate. And waiting for some time. So you can see some magic is happening. Actually, most of the workshop I handle along with BCs, and so you just practice it. So that's all. I think it is over. See, I just create one Gmail account today for this FTP. That is why it's verifying me for to giving some more credits. So actually, it is be 400 credits in the start time. So here, I know that is neural networks. And here also that slide, like our PPT, it can be shifted to or here something like that, that everything that it's an amazing. So once you think about we are be creating a PPT that I think it may take 1 minute I think 1 to 1.5 minutes to complete this PPT. So while we doing usual practices, how much time it may take. And also if you want to edit the themes, so here lot of options. So this is the one theme, and if you want to like set up this theme, so it will be changed to accordingly. If you want to change into another background, so many options are there along with this, and sometimes somebody has to be like that is in black color themes. So if you want, you can be accordingly. Then another thing is that if you want to edit anything in this, you can do that editing over here, no issue. And if you want to change anything, this image, if you want to change, you can change this image. Or if you want to add the notes, you can add the notes by clicking in this in and every PPT. So everything that is be heading also will becomes like fundamentals. And here this structure is comes. And here this so many that features has to be constrained to prepare a PPT like this. Okay. And another one is that another question is that can we share to this one? Definitely, you can take this one and you can share option over here. Sorry, export option over here. You can export to your PowerPoint. So export to PDF. So then after that also you can change anything from your like PPT side. So that also possible. So that one of the previous speaker also talk about this gamma. So actually that is you have to just practice this, and I think it is one of the like everybody is to be like this PPT. Okay, that is gamma. And next I move to my slide. So this one export. So click on that one. It be exporting the PowerPoint. I just to show you. Okay, now it is be downloading. So it is now downloaded. Yes, done. I opened this PPT. So that every PPT you have to look double time. So that in the LLM also that is we say in that way. So that same PPT that how feels. And I move to my slide. Gamma is over. Next, that is the another important like another one, that is napkin AI. So that we have to generate different like that PPT that we talk about, and we can like analysis also we can be taken by the notebook LLM. So if you want to like visualize the diagrams in that for this case, along with there are two options. So by pasting my text content or by generating text using AI. So the two options in this napkin AI for this creation of chart and visual diagrams. So I just gone through that. The visual, okay. I just loaded all the one because of this one. So see here, I just taken this one from our one of the paper. So that is annual global electric car sales. Okay, so that we'll get some data like this. So if you want to draw a chart, means nowadays what we'll do, we'll go to the Excels and we'll make the charts in different manners. And there that lot of like technical knowledge is be required. If you have to come to the napkin, so you can create. So I just copy this content. Yeah, just to copy this content. So any content you can copy now. So from the net or from our notebook LM, that synthesis or analysis you have to copy. As a researcher, you have a lot of analysis will be there for the literature and for the paper presentation, etc. So you have to copy that analysis part and click on the new napkin and create a blank napkin. So it will be creating. Okay, it's a blank one. Okay. My net is show you from here. So recent search. Yes. Yes. See here, generate visuals. One symbol that is in the side will come. So if we click on this one, so like the pattern that is will be over here. If you want to change this into another this one, you can be click on this one. If you want a graph like this, you can be select this one. If you have to go more, so if you want a pattern like this, so you can be created a pattern like this. If you have to go behind this Excels, it may take so many times to generate a visual like this. So it is very easy that is we plot this one. And here the option, that download option is also will be there, export visuals. If you click on this one, you can be generating PNG, SVG, PDF, PPT, etc. And also another thing, while we considering as an like now engineering faculties, we can have see this one will be here. So I'm generating another thing by this. So here the categories. If you are to looking this, that is these are the AI suggestions. So that is also very important. So AI suggests that these are the suitable for these visuals. So you are giving the like no, this text, copy this text, it automatically like suggestion will be coming from the AI side. So if you want to mind map, so like previously we talked about like this type of things, if you require, you can click on this. And if you want to process chart like this, if you want to a process chart like this, so then you can click on this one. So that chart will be like changing accordingly. And if you want to a data like data driven approaches, you can do this one. If you want a timeline chart or something like that, you can select this one. Then here like narrative, that is hierarchy based. So any things you can be select from these categories. And here that is a another giving that suggestion. If you want to chart like this, we are just giving the data, and the AI systems like our system will be generating that is the most like suitable one from the AI. That is one of the, like as an academician, you just copy this one and you can take it. So here also in this slide I included one accordingly. See like this figure. So I'm giving that intelligence and the ultimate goal and these things, and the system will generate an accurate like so many images are there. So from that I consider this one. Okay. So this one I am that is taken from that our napkin.ai. Okay. And here this one that is text to like in the visual diagrams and our chat operations. So like 15 minutes more. Okay. And here that is multi modality beyond to text vision and audio. Actually, I have a plan to do one more thing like cursor AI. That also very important. Like an academicians, like that is no visual code, Visual Studio Code. So in Visual Studio Code, that is we giving that like a framework, IDE framework, framework that is most of the that is helping the program development. That is we are using a framework. So in this Visual Studio, so like above the Visual Studio, like I'm say that above the Visual Studio, it's like that we call the cursor AI. The cursor AI that is actually be act as like a Visual Studio, and plus it is having a AI inside. So cursor that means it's called cursor AI. I just to show you that one cursor AI. That is in the programming side. If you are interested in programming side, means that you can be also go to like cursor AIs. It takes some time to run. Okay, by the time we will just go these slides and here the applications. No. So virtual assistants like Siri, Alexa, Google Assistant leverages. So here also that real world examples of this they are be using these LLM applications and conversational AI like like no ChatGPT and already discussed ChatGPT, Llama, etc. So there's also be used and content and code creation. No, LLMs power tools like GitHub Copilot and Jasper AI and assist with the programming, creative writing, translation, summaries, numerous other generative tasks across the industries. And what is the impact across the industries? This LLM will be considered. So, like customer service, so that is automated, that is natural conversation, that is 24/7. So if you have to be do like an human, so there are we can handle 100 calls at a time or 2 calls at a time. So but in AI, if you have to be create like this, like chatbots that handle like more than the humans. So content creation. So like we are already talk about research and content creation and generation and design and this creative brainstorming, this LLM acceleration workflows for marketers, developers, and artists. So okay, and education. So personalized tutoring adapt to individual learning styles. So if you like create like that and language learning homework help and instant explanation and make educational work is like no access. And the research accelerating the literature already we discussed, and healthcare application like summarizing medical records, analyzing research papers in the healthcare, and assisting with the diagnosis, and it'll help to clinical faster and more informed decisions. Okay, and this is a future LLM. So like laws are be there, need to be customization, AI operating system. That is another thing that maybe uh, comes like self improvement and physical integration. So that means the LLM will become increasingly integrated into every aspects of digital life, serving as a universal interface between human and technology. So that is my things. So any things like in AI, that is the critical challenge and ethical considerations will be there. That is hallucination risk already discussed our previous speakers. So that is a rate very dramatically from 5 to 79% depending on the domain and models. An algorithm bias, training data bias risk will be there. That is potentially disadvantaging and uh, interested groups in educational outcomes like privacy and security, like student data protection and institution information security. That also will be a very constraint in that. Okay, in using this GPTs and long-term impact. So urgent need of studies, understanding cognitive development, learning retention, and potential unintended consequences of dependencies. So so these all are about use cases. So that I just one more use case I already told you, like cursor AI. So here, no, that is in cursor AI. So here, one agent will be also will be there. So it seems like that is our normal our visual codes. But in addition to that, there are a lot of things are there. So it is including these agents like GPT agents. So here you have to like agent is the will be there. Planning you can be done and debugging we can do. And here yes. And here you can set up here auto agents and things we can be considered of here. And here new text files, and if you want to open, you can open it and you can do. So that that is in normal things in small if you're using some GPTs are not be in the free version, but in paid version that most of the all are that is not most of the that is professional things will be working. Okay, if you want to plan, you can be change this mode to plan, and you can be do the things. And here, if you want that you can be script over here. So accordingly, that will be generating the code. So for Network is slow. So that will be reviewing, and accordingly that will generate these things. So you have to say like, so they are asking the options. What is the main purpose of the FTP website? Information. So accordingly you have to answer one by one. So either you can skip or continue. So if you have to be set up one by one, and after that, if you go to the run and run without the debug and run with the debug, so you will get an exact overview of this like your course. So here that is another that you can be use cases that is Cursor AI. Also that is you can use for your like for to if you are to planning anything like like for coding side also you can use this. Okay, thank you. So I just wind up the session, and thank you for your listening and the patience. So like that is the third slot is given to me, and I already talked to Amal sir that like 5 to 6:30 means. So it's very horrible to that audience, but sir is saying that to all our faculties, and they'll be very interesting, and they'll be very enthusiastic to be as part of these things. So once again, I thank you all. So if you have any doubts that we can be clear within 6 minutes, we can be clear the things. Thank you all.
Thank you, sir. It was a very informative session, especially for the academicians. How there isn't any detailed session on some specific tools. Instead of knowing the names of 100 tools, if we can master one tool, that will be the best way. I think we can make our job much easier. So in that angle, it was very informative and very fruitful.
Oh,
So
thank you, sir. Thank you.
yes, yes. So we have few minutes for the Q&A. So have any doubts, please.
Actually, that practice it. So from the practicing, we learned so many things actually, and also day by day that like no that output also it is more accurate because that another thing that is if you want to like no set up like that open commercial open AI commercial also available. I think I just to show you that for anyone has to be interested in like so all are remembering the things in the context. I just stop sharing. So just wait, just to show you that open access. And GenSpark also we can be used for the presentation for these presentations. But one thing that
Sir, one general one doubt is when we using this kind of AI tools, so how we can prevent over dependence of this kind of AI tools by the teacher. Sometimes I felt like in the short run only we might lose our ability to think especially critical thinking and all. So any best practices when it comes to
So that in my point, I'm that let's be always that looking that recent like no research tools or research technologies. From that, we will get more effective ones. So we cannot say to stick on one thing. So that is something that is be different. So in most of the cases, so we can be use Grok also you can use DeepSeek also you can use. So that no that is Tesla also be using like no their car is like driverless. So
yes.
they have not used actually that LLM, but they're learning their that is yesterday I think like shipment and all they be all they are be like no like set up their own like learning and their own things. So we got all this then all, we have to go behind always behind this that is new technologies, then we can I think we can be catch up these things in my point.
Okay. Thank you,
So
sir.
that we can't say that like GPT is better. So I'm not saying that GPT is always better. നമുക്ക് പറയാൻ പറ്റില്ല. It's not
Mm.
we can say like that. So ഞാൻ share ചെയ്ത് കഴിഞ്ഞാൽ so is it visible sir now my screen?
Yes.
Okay, so this is the like no open LLMs. So here these LLMs, large language models, are all licensed for commercial use. So that is Apache and MIT. That is not all. So like here you can say like from this 2019. So that is the release date. And if you come to down, that you can see like sometime that is Llama 2. That is a free if you have under 700 million users and you cannot use Llama output to train other LLMs beside Llama and its derivatives. Some license concern will be there, and sometime that is MIT and Apache that we giving and 23, 25. See, will comes to in bottom side, you can see like here. So that Tata Research Institute and cheaper, better, faster, stronger. So like introductions of Llama 3 and so some restriction in somewhere, but in latestly that one that is Ulan Mini that is by the MIT in 2024 and also in Apache that is be learned Sealan Mini in 2025. So by using this also that open LLMs for coding, if interested means can do like this. So open this coding and open LLM data sets for alignment for the tuning. And here the leaderboard that is I think the last speaker that is yesterday talk yesterday or before that they talk about leaderboard concept and all and LLM leaderboards by these and do the license means so are we things are we there. So while we setting all these things that if you are interested means you can be in deeply that faculties or interested LLM faculties can be go through these. So this one will get more insight over this actual this integration.
Thank you, sir. Some of them are asking your email ID, sir, in the chat box because I think they can. And
Yes. So okay, that
other faculties, those who are interested, you can invite Imitiaz sir for your
so
institution also for
actually
detailed
that is
discussion.
that is for as a company. So that is actually we are being a startup also, and also that like if time permits, we can do like that. No issue in that. So my chat, I think. See, that is, sir, can you sir, can you remove my screen share from there? So I think I closed down that one.
Okay.
Is it possible to?
Yes, I think it is possible. 1 second, sir.
Yeah. I'll show you my slide and my email ID. I'll put over there.
Thank you, sir. Um,
Thank
we have
you. Thank
some.
you, Amal sir, and thank you, especially that thanks to all and their royal family for inviting me, especially that Principal Dr. Suresh sir and his team, and from Amal sir, I think 7 to 8 months back, he called me and taking my that resume and say that we are be applying for Adel FTP. At that time also, I encouraged them and that is they invited and they give me a slot also for this FTP and the entire team of the Department of like AI and the entire team of the royal family. I congratulate all for that will be hosting a wonderful FTP in Atal and also the congratulate Adel for giving an opportunity to the new trends in the like this era in the to like FTPs in the colleges. They are giving the funded and support. So giving that is congratulate and thanks to Adel also. And once again, thanks to the management of Royal Engineering College. Thank you all. And
Thank you,
thank you
sir.
for
Thank
the
you for the
participants.
generous words and support. Thank you once again. Good night, sir.
Good night. See you.
See you, sir.
So, participants, thank you, sir. Thank you, Nitya, sir.
Thank you.
Participants, our feedback session is open. Please log into your personal Atal page and please do the feedback. After feedback, by 7 o'clock, the online test will be open. Only 7 to 7:30, the online test will be available in your portal. So please, all of you log in to your Atal portal and please do the feedback. And also by 7 o'clock, the online test will be open. After 7:30, we will be having our validatory session. Please do stay with us for the validatory session. Again, we have one eminent person who is doing the validatory session, that is Dr. Srinivasan, sir. Kindly be available for the validatory session, participants.
So, I congratulating everybody who have successfully completed the 6 days Adel FTP. So, once again, I reminding you all, now it's a feedback time up to 7 o'clock and from 7 to 7:30, you can complete the online test from the Adel portal. So, both of it won't take much time. Hardly it will take 20-25 minutes to complete both. Meantime, those who have completed feedback, they can switch on the audio, and give us a small feedback comment. How was the FDP? How was the session? How was the last session? So, I inviting everyone. We have some time. Almost we have 1 hour is there to start the validatory session. So, meantime. Please comes up and we can have a small discussion or we can give a small feedback on the overall FTP. A lot of people, Hardik Chowdhury sir, Anubham Shah, Dr. Shaili Bhatia, Dr. Nafla Iqbal, like a lot of people I have seen a very active engagement. Dr. Sia Paulos, So, yes, Hardik sir, welcome.
Yes, sir. Good evening, sir. Just wanted to say that I'm actually doing my PhD in actually deployment, especially for clouds and these technologies. So this FDP was very helpful for me, and especially so many people who have shown their practical applications working on different technologies in AI, especially yes, today also sir have shown a wonderful GitHub links as well in the end. It can help me around to test some of the application scenarios for my PhD requirements. So regarding this, I'm always looking for some people who manage to show such programs continuously. And in the beginning of year of 2026, this is one of the best FDPs I have attended, because people have taught practical people have taught lots of wonderful things regarding technologies and their use cases, and whatever implementation has been done so far, and how much India is also doing in that. I'm also thinking that if we do FDPs based on how India is also using these technologies, because most of the AI platforms are of other countries, like sir has shown us Napkin AI right now,
Yeah.
as well as Gamma, and some of the technologies are always from outside. We are having very less number of projects which are getting deployed from our country. So because of that reason only, I choose to doing my PhD in this sector, so that students will get help, as well as so many people who are learning coding and everything, but they are not deploying anything. That's why I just chose this platform, and this FTP, what you have done here was wonderful for me, because it gives me a very good pass to move on. Okay, so that's from my side. Thank you, sir.
Thank you, Hardik sir. All the best for your PhD and
Thank you, sir.
research
Thank you.
endeavors. Thank you, sir. Few more people can come up. We have time. Jayashree madam, Rakhi Sharma madam, uh, those who have completed the feedback, they can comes up and give a small feedback.
Yeah, hi sir. I am Rakhi Sharma from Gurugram. I am also a PhD scholar and a faculty member in a college also. So the FDP was wonderful, sir. It helped me a lot in my research. My research is in NLP itself. Um, it is text summarization in Hindi language.
Okay.
So it helped me because there were so many sessions which was on LLM and other applications. So I am really thankful to you, sir, for such a good FTP. Thank you, sir.
Thank you, madam. Thank you for the generous comments.
It is found that few participants still have a doubt whether you have to fill up the Google form that is shared in the chat. You have to log into your Atal portal, and then there you have a feedback you need to give. Click the link, you can do the feedback. The same you can do for the assessment of also. For the attending test also, the link will be open by 7 o'clock.
Yes, thank you, ma'am.
For participants who have any doubt regarding where the feedback link is available, log into your Atal portal and then click on the left side. You can see the feedback written. So just click it on. Then all the FDPs you have attended, it will be visible. Click on the the exclamation mark here provided. Then you can do the feedback and do the submission. The same thing you can do for the assessment also. Here, click on the assessment. The portal, the page will be open. Click on the link. Here, the date will be given and the start date and end date. Here, the link will be open. So, by 30 minutes, 7 o'clock, it will be open. Please click on the link and then start doing the test. The test will be for 30 minutes only. You will be having 30 questions. After 7:30, the link will be closed. So please do start your test by 7 o'clock. Okay.
Ma'am, I have one doubt that we need
Yes.
to be log in during the test or we can leave and join after the test.
Yeah, after this test, we will be having the validatory session. We'll be continuing with the validatory session. If you can stay with the validatory session, it will be very useful. Our speaker also will be there. So after 7:30, again for half an hour, we'll be having a validatory session.
Okay, so it is not necessary to log in during the test. I can leave.
After the
Is it?
test, you can leave the Atal portal. You can
No,
sign out the Atal
from
portal.
this
Yeah.
Zoom
Oh,
meeting,
from the
my
Zoom.
question
Okay,
is,
okay.
uh, uh,
That is
can I?
that is up to you.
Okay, ma'am. Okay.
test will be starting in a minute. All the participants, please do click on the assessment that is provided in the left side of your Atal website, Atal portal, and then click on the link that is provided, assessment workshops link. Then you can do the click on the start to start your assessment. Please read on the assessment guidelines and then start on the test. Its time is 7 now for 30 minutes, 30 questions. This is important for generation of your certificates.
Anyone available?
Yes, sir.
Ma'am, in feedback, some faculty names are resource person names are not showing.
Actually, all the resource persons' names are available in the
Only
feedback.
seven names are showing.
Okay.
Like last session Imtiaz sir was there. His name is also not
Yeah.
there.
Oh, not there. Okay, we'll check it out.
Okay.
So everyone, try to use your computer for doing the test, and try to use Google Chrome for the browser, because it's not working in mobile phone, and it is showing some errors in Google, I mean, in the Microsoft Edge and Safari browsers. So try to focus on these 2 points. So we will be starting the validatory session soon.
Good morning. Sorry, good evening, coordinators.
Good evening.
Good evening,
Good
coordinators.
evening, sir.
Good evening, sir.
So, what about our chief guest? Whether chief guest onboarded?
Hmm.
Can you hear me, Aman?
Yes, I can hear you, sir. I'm just actually everybody was a little bit stuck with the QCs going on currently. So
Oh,
7 to 7:30 is a time for the quiz, and feedback. I mean, 6:30 to 7 feedback, and 7 to 7:30 is quiz. So it is going on, but it's all almost over. The time is over. Our chief
Is
guest,
this over or whether it is going on still now?
quiz time is over. It's only up to 30 minutes, the quiz. Quiz they can conduct later also. They can try it later.
We can go with the validity ceremony,
Yes,
right?
yes. Right now, yes, sir.
You can check whether call the chief guest and see that whether he's on board or not.
He is not yet onboarded.
You can make a call to him.
Okay, sir. Yes, he said he will join right now. So we can, Sri Lakshmi Madam, we can start the session very shortly.
Sir, if you have put the messages regarding the question, actually they are unable to submit and
It's
the
okay.
session expire. So
It's
kindly
okay.
follow up with them.
They can do later. So our chief guest is joined. We can start the session.
So we are going for the valedictory. Good evening to one and all present here. It gives me immense pleasure to welcome you all to the valedictory session of Atal Online Faculty Development Program conducted from 19th to 24th January 2026. Over the past few days, this FDP has been a remarkable learning journey filled with insightful sessions, expert deliberations, and active participation from all our delegates. We now come to the concluding session of this enriching program where we reflect on the learning outcomes and formally bring the FDP to a successful close. To begin the valedictory proceedings, I invite Mr. Amal K. Thomas, Assistant Professor, AD Department, to deliver the welcome address and present the FDP report, highlighting the objectives, activities, and key takeaways of the program. Please take over, sir.
Thank you all. And first of all, a very warm good evening to all. So it was a very interesting last 6 days, evenings, especially filled with a lot of insightful session, 13 insightful session. So we have a 30-minute session today for the valedictory session. We have a very eminent personality here. Dr. Srinivas sir is one of the top pioneers in our domain, and our chief guest introduction will be given later. So let's not waste much time. Let's quickly, I will start the report, a brief report of the 6 days Atal FTP program. So the Atal Online Faculty Development Program, which is on energy efficient LLM model deployment on Edge and Cloud, which is happened between January 19th to 24th, 2026, represents a timely and a strategic initiative that addresses the most critical bottleneck in modern artificial intelligence sustainability. As the industry shift from merely building massive models to deploying them practically, this 6-day course offers a comprehensive roadmap for optimizing AI where energy and cost are constraints. The curriculum begins with the foundational efficiency where Dr. B. Surendran, Associate Professor, NIT Puducherry, sets the academic stage, followed by Shino Charvatur, EMEA Head of Discipline, Wood, Scotland, who would provide a global industry perspective on low carbon AI and fine-tuning techniques like LoRa, and this seamlessly transition into the hardware realities of the deployment with the critical insights on system on chip designs provided by Ritesh Tekevitil, who is the director of analog devices, Bangalore, alongside research perspectives from Dr. P. Revati, assistant professor from Pondicherry University. Midweek sessions broadened the scope to rapid prototyping and sustainability, featuring Dr. Ramya Durai, associate professor, Jain University, Bangalore, on LLM powered agent systems, and later Dr. Sunil Kumar, Professor, College of Engineering, Kuttanadu, on the environmental inventions. Later, the program also tackles the philosophical future of AI with Gopalakrishnan G, who is a AML manager in Turing company. He is leading a deep dive into AGI, while Dr. Manu MR, who is working in the Ministry of Education in UAE, discussed the deep learning techniques which is using in the modern agriculture domain. And later, crucially, the schedule balances the high level tech with urgent real world utility. So, Ms. Adira M, who is a CTO and a co-founder of Docker Vision, and Pradeep T, who is a senior data scientist in IBM, guided the participants through production-grade agentic workflows, ensuring the faculty understand modern industry standard. The final days focus on societal impact with Dr. Srinivasan K, who is an Kerala Agricultural University professor, addressing the flood and landslide mapping using deep learning algorithms and edge computing platforms. Later, Dr. Manu Madhavan from IIIT Kottayam, assistant professor on medical applications, which is using edge devices. And later, in the last session, Mr. Imtiaz MP, who is the CEO of CodeSpace, and he concluded the session with the most advanced use cases of AI tools for teaching and academicians to improve and accelerate the research and academic activities. So overall, this blend of global industry leaders from ranging from Scotland to Bangalore, and academicians ranging from NITs and IIITs, all central universities and all. So all over this, it was a successfully equip educators to teach the next generation how to build affordable, accessible, and environmental sustainable AI for the future. So it's a brief report on the 6-day FTP, and I'm taking this time to sincerely thank our respected principal, Dr. Suresh sir, for giving me an opportunity to being the co-coordinator of this program. And I thank Atal for granting the fund to conduct the program, and taking a moment to thank my dear participants who actively involved in a very active QA and follow-up discussions. So thank you once again, and over to you, Sulishmi madam.
Thank you, Amal sir. Thank you, Amal sir, for the warm welcome and comprehensive FTP report. It is my proud privilege to invite Dr. Suresh Venugopal, Principal RCET, to address the gathering and share his valuable thoughts and encouragement. We request you to kindly address the gathering, sir.
Thank you, Sri Lakshmi. And I hope I'm audible.
Yes, sir.
Yes, sir.
Yeah. Most respected, one of the topmost academicians I've seen in my life, Dr. Srinivas Madhusudan. He's not only an academician, he's a mentor, he's a brother to me. Thank you, sir, coming on board into our FTP program.
It's a privilege.
And dear HODs, co-coordinator, Professor Amal, teaching, non-teaching staff members, administrative staff members, participants, esteemed resource persons, students, PG scholars, ladies and gentlemen, a very warm good evening to all. Immensely pleasure to be here when we just rewind for 6 days. The day we started our FDP, AICT Atal funded FDP, online FDP on LLM deployment, energy efficient LLM deployment on edge and cloud. So from the day 1 to day 6, when we just count on the days and the sessions happen, we have already touched almost the nook and corner of the areas. Like if we divide the whole FDP title into 3 main areas, one is mainly what is LLM, one is how to make it energy efficient, and the last one is like deployment of the LLMs on edge and cloud. So we had esteemed resource persons from academia, from industry, from R&D organizations, And I'm really happy. And I let me take this time to sincerely bid my appreciations to the whole team behind this FTP, because it's a huge work from their side, the whole committee, the subcommittee, the members, and the whole volunteers who took their highest effort, sincere effort for making this FDP, Faculty Development Program, a grand success. And faculty development program, the word itself, faculty development, the whole faculty, which is the backbone of this nation. Teachers are the backbone of a nation. And when teachers develop, when the faculty develop, we all are facilitators actually. When we call ourselves as faculty member, we are facilitators. We should facilitate our students who are going to the future national builders to think about the recent technology and what is right now going in the industry and in the R&D organizations. So AI, ML, artificial intelligence, machine learning, LLM, large language model, and the huge energy consumed by the data centers, which are to be thought in a very curious manner, very serious manner, so that we can make it energy efficient and slowly we can use AI and ML, which is one of the topmost technology, but without much wasting energy. And I'm really, really thankful to all the esteemed resource persons who took their time and effort to get on board in our platform and to make this FDP, which is conducted by the Department of Artificial Intelligence and Data Science of Royal College of Engineering and Technology, a grand success. So once again, we are just waiting to hear the words from one of the inspiring person, Dr. Srinivas. I have met 2 3 years back, and I know how much he is thinking about, like, to make the students to come up with their own idea and to convert that to a startup, and that too in cutting edge technologies. So once again, I'm reading my sincere thanks to Dr. Srinivas, who is our chief guest right now, and all the sincere appreciations to all the participants, resource persons, and my coordinators for conducting this FDP on energy efficient LLM deployment in an edge and cloud in a grand successful manner. Thank you very much. Jai Hind.
Thank you, sir.
Thank you, Suresh sir, for your inspiring presidential address and for your constant support towards academic excellence and faculty development. We now move on to the most awaited segment of the evening, valedictory address. Dr. Srinivas Madhusudan is a seasoned healthcare technology professional with over 70 years of experience spanning healthcare IT, product management, clinical systems, and digital health solutions. He has worked extensively across domains such as EMR, EHR systems, hospital information systems, clinical research platforms, and healthcare data management, with strong expertise in aligning clinical workflows with technology. He has played key role in product strategy, solutions architecture, and healthcare innovation initiatives. Currently, Sir serves as principal consultant and head of operations for medtech and geriatric healthcare technology business incubation, contributing to the development and scaling of the impactful healthcare technologies. It is a great honor to invite Dr. Srinivas Madhusudan Kandadat, Principal Consultant and Head of Operations, MedTech and Geriatric Healthcare Technology Business Incubator, to deliver the valedictory address. We are grateful to have you with you, sir. Kindly address the gathering.
Thank you very much, Ms. Sri Lakshmi. And I would like to thank profusely Professor Venugopal, Suresh Venugopal, who was kind enough and generous to speak nice things about me. And I would like to also thank the chief patrons, Mr. Haider Ali and Mr. VP Salim, if I got the names correctly, and for patronizing all the FDP program, because FDP programs are the lifeline of academics. I know there are tough times for the academicians, but that's how the next stages, which are in the futuristic, either from industry or other areas, are brought to the academicians, and academicians start excelling and improving themselves, because they are the builders of the nation. That having said that, I would like also to thank the other dignitaries, which include the professors, HODs, assistant professors, and others, the esteemed faculty members, and participants. The concept of energy efficient LLM model deployment on edge and cloud itself is a futuristic concept, at the same time combining with it the sustainability model. Now, generally, the futuristic and the sustainability models do not really work out at the beginning itself. It's like involving sustainability in the design itself. Now, this FDP program has taken that a bit further, where it is involving the sustainability at the time of the thought process, the origination in the faculty members who further go and provide the same inputs to their students, by which it goes to a step of pre-design, wherein we say that, when you are young and other things, there used to be this great language debate, that, when people from the vernacular medium come and to English medium engineering colleges, they used to say that, you're supposed to be thinking in English, whereas the vernacular people may not be able to think in English, which is not generally, there's no great thing. It is only those days we used to think like that. So, but here there is a vast difference. Now the students pre-design are being designed to think sustainability while developing their models, or even their thinking, wherein either they go to hardware or software, or at the semiconductor level, or at the intermediary level, or at the LLM development, or at their deployment, right? You see the vast, or in the applications of where I have seen an array of applications. I was very, very happy. Straight away, starting from the efficiency model to where all it can be applied through forestry, through agriculture, through medical applications, and it was encompassing everything that can be impacting. But of course, once you call me, I have to add something, and I would like to add, next time, please add marine and security entities also, because there are one or two items, the space technology is also as a separate entity, because Kerala is poised to become the biggest semiconductor and space technology state, if everything goes as planned by the semiconductor mission and AI mission, because these two come together. The reason I'm introducing that here is the faculty developing program, so well designed like this, take the energy out of the faculty. Let me be very frank about this. Unless there's something where they can show what they have acquired in such sessions, both with their students and with the industry, there will be kind of, please permit me if I am using the wrong words, of depression. I'm telling you the right vocabulary for this. Depression, indifference, and lackadaisical attitude, because it will be just like another thing which is decided by ACT and other people. Let us go for 6 days, sit there and come. There, the spirit of such well cured and well structured FDP programs is lost. So this one has to be, because the follow-up becomes very, very important. And now there's a huge burden on the shoulders of Professor Venugopal and others who have initiated this FDP, because now is the time to identify what is happening in and around Thrissur, what is happening in and our Kerala, or what is happening in the national institutes, because Professor Venugopal has a connect and also has the knack of holding to the connections. Here is where it becomes very really interesting. For example, Tata is going to set up the semiconductor based AI based semiconductor fabrication systems in Mallapur. I came to know that Netra has set up, of course, it's a fabulous, but still AML. And the forestry department is also looking for how to protect the forests from the external people. Because in one of the discussions with the forest department, they said, we can take care of animals. How do we take care of the intruders? So these are the concepts. And the most important thing that we always forget is the marine ecosystem. Now, let me come back to the LLM and energy efficiency system. In the beginning, I said this is both sustainable and futuristic. Generally, futuristic systems consume more energy. There is no way that you can escape from that. Once you achieve it, then you can think of sustainability measures and energy efficiency. Since you have started off on the energy efficiency model, this has to get into your curriculum. That's a very big step. How to bring it into your curriculum. And the other extreme is about the applications. Really, we spoke about the forestry and other medical, agricultural applications and other things which can be extended into marine, etc. Now, is there a continuum of it? Why I'm saying these things? Because the intermediaries are very, very important. We tend to find an easy way out to the societal applications because we have been over a period of time too much of a socialistic attitude, and wherein the science takes a back step. We say, okay, you are doing this. How is it useful to the society? How is it useful to the common man? Even today we hear the word affordable and other things. Yes, ultimately it has to reach the goal. But every journey starts with a single step. At that step, it is not affordability that counts. It is about the first step that counts. To understand from where the funds come for that taking that first step, to understand where the resources can be accumulated or pooled in, because none of us are very rich, wherein Trump can write one signature and you have millions of dollars to be spent. We don't have such luxury. What we have the human resources, we have the best brains, we have the best academic entities, we have the opportunity of the industry coming up. We are on the sunrise. We are a sunrise nation. It's a this is the revolution that is happening, wherein the what we can say the smart industry revolution is yet to take out, right? We may say about Taiwan, which is already there. There are two benefits of it. One is we need not fail because stories are already there. We can follow the success stories because we are not pioneers in this field. Two, till now, we have been doing the fabless and other things in the semiconductor. We have started out with AI based. That means many stage gates we have passed away without going through it. It's like, wild entry pass. Once we get wild entry pass, the best thing that happens is a faculty development program which understands or which provides all the inputs that are required for that so that the next coming generations are tuned to that. Having said that, I would like to speak something about the faculty development program. There are different versions of definitions of it, ICT and others. I have my own definition, some with it and some apart from it. Everybody doesn't become a faculty because they love teaching. Here, I'll say give another statement. Please keep that in mind. Those who can't do become teachers. Just keep that in mind. Is that correct? We'll think about it. But let's come back to the faculty people. When you look at the academicians, they are the ones who are at the new cutting edge technologies, not the industry. Each time an industry is, because I'm on the threshold morale of both industry and academics and in a national institute, so I can observe both the patterns that are developing in the industry and the pathway the academia are taking. The industry keeps on changing its goalpost. So each time, academia cannot keep on changing their models to keep reaching the goalpost, the changing goalpost of the industry. Because today some technology is developed, the technology is being taught in the academia. Academics missions are preparing the children to work on those technologies. We speak knowledge and other things. Essentially, we are developing the employees of the industry and the academicians which come in the future, right, or researchers. In these circumstances, we have to have a translationary approach because academicians cannot quickly change and adapt at the speed at which the industry moves away. And the industry keeps on complaining that the students coming out are not industry ready. Academicians are not supposed to prepare industry ready students. First thing, they are supposed to prepare develop the potential of students that they can be turned very quickly into industry ready by the industries at whichever goal post that they want to post these students and the freshers so that their goal posts are achieved faster. This is very important thing that we have to keep in mind because the pressure of industry and the social media is so much that our academicians are not producing the results as per industry. First thing. Second thing is industry academia collaboration following such FDP programs to squeeze maximum out of the program because the freshness of the program gives that enthusiasm to the academicians. Today you may be tired. Tomorrow when you go, take a leave and think about things, introspect what you have done in 6 days. You will know that you have made a giant leap. But how do you utilize the potential that you have gained to the giant leap? One way is the students. But do we have the wherewithal to implant all this knowledge into the student's brain is one thing. Second, what are the different schemes which give us funding, both at the center level and the state level, which will help us to develop this because these funds and schemes are under different heads, so confusing, so wild that today you apply, you will get only after 18 months to 2 years and things. So there are the different elements to it. Now the problem would be, do we have the knowledge of cloud orchestration techniques that reduce energy footprints while scaling AI services? Did we develop the interdisciplinary centers inside the college itself? Because most of the colleges I find are silos. One thing I liked about the Royal Engineering College is still has the mechanical engineering. Somehow these days the engineering colleges are working, trying to close on the mechanical engineering. But believe me, mechanical engineering is an evergreen subject along with electrical and electronics. Please remember that. Now, how do you connect AI/ML and energy efficient systems both with electronics and communications engineering, with computers and software faculties that you have, along with the mechanical and other things? Only then real-time projects will be coming up, both as the ultimate societal products and also intermediaries. For example, the semiconductor fabrication to any product that you are thinking. What are the intermediaries? Take a list of your system, which is your favorite. Your favorite could be healthcare, agriculture, marine, forestry. But depending on what was your background, some of you must have come from semiconductors. Some of you must have come under AML directly. So please look at it. Come together, make a interdisciplinary team, and only through interdisciplinary team, please deliver the projects. It is only thereby where a single phase of Royal College of Engineering will be seen by the industry, and the take up of the students by the industry will improve, and it is really that which the parents as well as the academicians are working. While we are speaking of the industry, I would like to go one step further and speak about the startups by the faculty themselves. When I say startup by the faculty themselves, please understand one thing. I am not speaking about small time software applications, which even the projects of the students can be done. It is about those applications which can be built through years, like take 5 or 6 years, not only with the students, but with the alumnus club, and also with the students who have left that and are working at different entities in the, because it's all online, and can have different student groups interested in different areas. Please understand the semiconductor fabrication development program with Tatas in Malappuram is a boon to your college. Identify what all intermediates can be developed. Please work on those areas. Please make them into smaller and smaller projects, just like the way we do in the what we call that work breakdown structure, right? We understand the work breakdown structure part of it. So everything that goes into the work breakdown structure, everything that goes into your product development, please make into the smaller projects. And I also find this very amusing that each time a new student comes up, and or a new batch comes up, we would like to give completely new project. Oh, this has been done by that batch. This has been done by that team. Please believe in continuity. Please believe in the smaller steps. Please identify the points where patentability can be developed. And now this is the game. What to publish, what to patent, from which patents a product can be developed, from which products a startup can be developed, how the startups can have a policy at Royal College of Engineering, so that faculty can develop beyond their academic things, academic activities, into the industry and become bridge between the academic sector and the industry sector, even while some of those benefits are accrued by the Royal College of Engineering for facilitating all these activities, because we all work during the time of the academic tenure itself. So we should be fair share, a policy which will have a fair share for all the people involved, including the students and the alumnus and the industry. Now, I would like to have, I know you may be knowing all these things, but I would like to emphasize some of the schemes, like the centers of excellence for AI and energy efficiency schemes, and the B is ADWET TIE scheme, which is have the global and private programs also, like NVIDIA, Google Cloud, EU Horizon from Europe. Please look into these schemes because there is that gentleman. I don't know whether you look at this ad from Lalita Jewelers. He comes with a bald pate, and I forgot his name. He says that money has to be hard earned. It doesn't come for free. Whether it is college, whether it is academicians, whether it is parents, whether it is the industry, or whether it is students, money doesn't come easily. So we have to work hard for that. We have the India AI mission, which has launched to build a national AI ecosystem. Please find how to mine it to for the computing infrastructure of the GPUs, cloud credits for academias, your own startups, and when the startups become MSCMEs, or when your college becomes the consultant with the MSMEs, we are ready to support in that. And the research grants, how industry and academic collaborations into the research grants, fellowships, and innovation hub for AI development into healthcare, agriculture, and the marine systems. Because Kerala is looking at agriculture and forestry. Believe me, there are billions in the marine system. I request Trishul to look into the marine system and marine security. And the GPU allocations, which India AI Compute Capacity Program. We can discuss it on other things also, but I wanted this point to let you know that there is money flowing in the system under this government. The central government is just open the gates for money. It is for us to tap that money and use it for the faculty and for the college and for the students. We have the this compute capacity program is focused on energy efficient LLM training and inference on cloud platforms. Please look into it. And then you have the centers of excellence, and also the ADIT, ADWE scheme that I was speaking of is from Bureau of Energy Efficiency, Minister of Power, right? Because they are the real ones who really need. We have to make a connect to them and see what are all the schemes are there. Your project should be in tune with what you have gained now, and show them that this is the kilowatt hour that you are consuming now. If this project is financed or budgeted for, we'll be able to give it by the 30%, 40%, or whatever that be, so that the college faculty and the students can work on real-time projects along with alumnus and other industry that have moved ahead from the Royal College of Engineering. And then the beyond this sector which we are usually interact with, there is this EU Horizon Europe. This funds projects on green AI and sustainable cloud computing. There's a lot of money there. Please look into that if you are not already looked into it. Then you have the NVIDIA Inception program. And I know you must be knowing, I have seen that somebody was speaking of the cloud research credits. So you must have already got some information on the Google Cloud Research credits. Then you have the World Bank and UNDP programs, which grants especially for AI in agriculture, forestry, and climate monitoring, all covered by today's, the 6 days intensive faculty development program, one of the best curriculum I have seen in faculty development programs. Then we can discuss later for about the application processes, the global grants, how to scale it, and other things. So this is what I wanted to showcase. I know I have taken a lot of time. Went beyond my thing because I know Professor Venugopal. I know his energy. So I wanted to transfer through him what we are thinking for the cause of the nation and for the cause of the states, so that the energy consumption of LLM computing system hosted on cloud in India. Remember the words I am marking. Hosted on cloud in India, because you have seen sometime back, a couple of days back, Trump saying that India has to pay for the chat GPT because they are paying for all the energy that is there. So soon we are going to have to develop our own hardware, our own hosting, our own local cloud, where the clouds will be is based on the servers based in India, especially because healthcare, agriculture, marine, and security, there's a common thread that is very high risk on all these things, including power supply, that is the cyber security. So there is a several layers of infrastructure and workload design that is involved, and so that this has to be taken up right from the large LLMs to inference workloads, through cloud infrastructure, and through the application domains, and through hardware and optimization. See how many domains are being covered under this. And now finally the sustainability considerations, which you also have covered. Here I end on a high note, because I know there's a lot to process what I have said, and but I wanted to push it into the thing, your system, so that you can sit, discuss, and restructure the project systems to suit the FDP edge that your college is having beyond other FDP curriculum, and take the students and the nation forward. Thank you very much.
Thank you very much, sir. Thank you
Thank
very
you.
much.
Thank you so much, sir.
Thank you, sir. Thank you, Dr. Srinivasan, sir, for your enlightening and thought-provoking valedictory address. Your insights have added immense value and provided a strong takeaway for all the participants, especially regarding the definition for the FDP. Sir have already mentioned. So it was really a very nice session now. Thank you, Srinivasan, sir.
Thank you very much.
Now, to formally conclude today's session, I invite Ms. Najia Abdurrahman, Assistant Professor, AD Department, to propose the vote of thanks. Ma'am, please proceed.
Respected Chief Guest Dr. Srinivas Madhusudanan, Principal Dr. Suresh Venugopal, esteemed resource person, dear faculty participants, and my dear friends. On behalf of Royal College of Engineering and Technology, Department of Artificial Intelligence and Data Science, it is my proud privilege to propose vote of thanks for this valedictory session of the 6-day online faculty development program on energy efficient LLM model deployment on edge and cloud. At the outset, I express our heartfelt gratitude to our chief guest, Dr. Srinivas Sir, for gracing this valedictory ceremony and for delivering an insightful and inspiring address. Your valuable thoughts and rich experience have truly added depth and meaning to this program. Thank you, sir. I sincerely thank our principal, Dr. Suresh Sir, for his constant guidance, encouragement, and unwavering support, which played a key role in successful conduct of this program. Thank you, sir. I extend my sincere thanks to our management for their generous support and encouragement, which made smooth organization of this 6-day FDP. I extend my sincere thanks to all eminent resource persons for generously sharing their expertise and making each session engaging, informative, and impactful. I would like to convey our special thanks to Amrita Ma'am, HOD, Artificial Intelligence and Data Science, for her continuous support and encouragement throughout the program. I also extend my heartfelt appreciation to all the heads of department for their cooperation and support. I express my sincere appreciation to all faculty members of Department of Artificial Intelligence and Data Science for their tireless effort, teamwork, and dedicated approach towards the successful completion of this FDP. I also thank Mr. Amal Thomas, co-coordinator of this FDP, whose dedication and selfless effort were truly commendable. I would also like to extend our special thanks to comparing team under Miss Sri Lakshmi and Miss Rishla for their confident anchoring and support throughout all the 6 days. My sincere appreciation goes to Posture Committee under the leadership of Miss Radhika for their dedication and excellent visual presentation of the program. A special thanks to Network and Technical Team led by Dr. Pradeep, HOD CSC, and Mr. Subish and Mr. Sam for their ensuring smooth technical operation and uninterrupted online session throughout the FDP. I also thank Registration Committee under Ms. Swadi and Ms. Grishma for smooth handling of participant registration throughout this FDP. Finally, I express my sincere gratitude to AICTE for providing this valuable platform for faculty development program, and thanks to all participants of your active involvement and enthusiastic participation. With this, I once again thank all of you for the cooperation. Thank you.
Thank you,
Thank you.
Najia ma'am. Thank you, Najia ma'am, for your heartfelt vote of thanks. With this, we come to the end of the valedictory session of Atal Online FTP 2026. On behalf of the organizing team, I sincerely thank all the dignitaries, resource persons, participants, and coordinators for making this FTP a grand success. Wish you all a continuous success and look forward to your participation in future academic programs. Thank you all. Have a pleasant evening. Thank you all
Thank you all.
participants.
Thank
You
you
can
all.
download
And
your certificates from the Atal portal.
Thank you.
yeah,
Thank you all. Thank you all.
thank you, Srinivasan sir, once
Srinivasan.
again. And we will definitely look into the India's semiconductor mission, especially in the Malappuram region. Definitely, we will have a
Yeah,
visit.
Amal, we need to collaborate with Sir. As Sir is one of the pioneer in startups and all, no, and he is
Yes, yes,
heading the whole TBI, Technology Business Incubator in IIC Bangalore.
yes, yes,
And he's such a person who is continuously thinking about how to make some ideas into product. So
yes, sir.
surely, sir, we will collaborate with you. Thank
Thank you,
you.
sir. Definitely, sir. Thank you. Good night, sir. Good night, all.
Good night to all.